Yeah, I've been muted the whole time. Look at me talking to nothing. I was talking about the camera and how stupid it is and how little inspiration I have for music. Sorry about that. I am unmuted now. That happens periodically. Yeah, this camera had to move for a doctor's appointment, so I'm trying to like get it to look normal again. And in doing so, I have to start up music and actually start my stream, which you will not hear the music on YouTube, and you will not hear the music on the VOD, but it needs to be there. We'll do a little 2040. Sorry, 19.8XAD. I don't know how loud this is going to be. Loud. Yeah, I was talking to myself. Wex, I spray painted something today with that the silver stuff that you sent in. You know, when I was trying to anodize stuff, the paint that you sent in, I took one of those little RC car bodies and I sprayed it with stuff. So right now I am basically basting in spray paint fumes, so it should be a pretty loopy stream. It'll be fun. I said Wexo, and my talking Amazon lady thought I was talking to her. The old cam was good. The Logitech cameras, it forgets the settings of them. This is a little loud, isn't it? It fills the audio space a little bit, the 20x AD. Okay, so what am I doing? I'm actually opening up my chat on YouTube, popping that out, and then closing YouTube. All right, there we go. So now we've got everybody's chats are up, and now I can try to calibrate this camera. So setup, face procedure. There it goes. Okay, cool. So now we're full frame rate. I look like I have blood in my veins, not too much. And the brightness is all fixed. Why does Logitech default to that? Why does it default to the settings? Yeah, we're doing a book day, but we got to make the fish noise, bro. Do you make the fish noise? Do you make the fish noise, bro? You got to make the fish noise. This needs to be more centered on my face. Actually, I need to move over. The lamp is crowding me out of my area. What's everybody else look like? This one. That's serviceable. These cameras haven't been unplugged, so they still work just fine. That's a good one. That's me. That's a microscope. We'll be using that today. Yeah, it's the Logitech default settings is what that is. There we go. So we are going to be breadboarding again, but we'll put this one aside and we'll use the other breadboard. And I'm going to make room for the big effing book. The big book. A place for everything and everything in its place. Hey, Smith Clay. Well, hello there. Obi-Wan. I mean, those movies being memed to within an inch of their lives, every atom in the prequels has been memed, has helped them gain a slightly more affectionate spot in the whole zeitgeist of bearded fans of things. But they're still not great movies. I think everybody's gotten to a little bit too much of an impression of them. How's BTS coming along? You got a couple things left to do with it to shore up all the hardware. I haven't done any wiring, but we have proven out the laser and PETG prints. I saw a print the other day where they turned up the nozzle flow rate a ton, and that ended up water sealing it. But in our case, what we did is we put UV epoxy inside of the laser diode carrier and then exposed it to UV light, and that has sealed it. And I let it sit for a month, and then I heated it up again. Still works fine, so I'm willing to trust it around my block of wood. Why do I have the hiccups now? I'm willing to trust it around my block of wood. And so now I move on to mounting everything on the wall and wiring all the internals. Those are two things that are going to take up a little bit of time. But we're gonna spend at least 1 or 2 days a week working on Burn the Subs until it is done. There's a lot of improvements going along, I keep getting shit from people about not working on Burn the Subs. Oh, is that going to be done when Burn the Subs is done? It's like, go build your own then. And then you hand burn my name. That's not going to happen. Unless I attach knobs to it and have little electronic knobs where I can move it around. But like anybody else is they can go build or Burn the Subs. I'm not claiming sole proprietary rights over Burn the Subs or anything conceptually near it. Yeah, it would be a big Etch-a-Sketch. I mean, that's essentially kind of what I'm going to be building when it comes to defining the borders of Burn the Subs, because I would like to be able to just plug in a USB controller and have Python use that in order to move the gantry around, so I can have it with its own internal numbering, you know, however it numbers the pixels or the millimeters. It can just make its own keep out area. Not make its own. I can make a keep out area. Or I could do a laser distance sensor. I was thinking about a laser distance sensor, but I don't know if I'm going to go around and do that because the accuracy of the laser distance sensor is somewhat called into question. At least for 3D printing, it's not accurate enough. So I don't know where that takes us for etching. Probably in the realm of, well, it'll kind of work if you get that all wired up. All flyered up. Flyered up is a phrase that they use a lot around here because of the Philadelphia Flyers. Capacitors will probably come in handy to make the fish noise, but we'll find out. I guess we'll just find out. I gotta make a little room because that book is big. It's not called the big book for nothing. The big book of circuits. And it's full of ideas that are very, very old. It's full of some really bad ideas that are very old. Hey beginners, hey kids, you want to learn about electronics? Take a 1 to 10 transformer and stick it in the fucking electrical socket, you little shits. Anyone who survives can then learn about how circuits work. You still with us? How are your nerve endings doing? Jeez. Just the most irresponsible fucking thing ever. And you see it constantly in these old books. That wasn't that bad of a shock, Timmy. Have another cigarette. It's healthy. Huh, where'd that other screw bin go? I had another one of those countersunk screw bins that I meant to put in its place. Traveled somewhere. The good old day, yeah. Clean off that thing with gasoline. Have an open container of gasoline in your kitchen. I saw some newsreels of that. Let's see. Apparently gasoline can clean fabrics in a particularly good way, but you wouldn't catch me slipping and sticking that shit into a washing machine. Hey, heating element, guess what? I don't know where that other kit of screws went. I bought these little countersunk screws because they're the same size as the RC car screws. The RC car uses the Atomic rather. The Atomic brand RC car uses a particular type of countersunk metric screw. Here's the rest of the stuff. There's nothing there. Surface mount caps, but it uses this particular brand. So I bought 2 packs to try to get the right size on Amazon, and they're floating around the shop. One of them was under the milling machine. It had been kicked under there, and I don't know where it is now. How's everybody doing? It's Friday. I had a doctor's appointment yesterday that went kind of okay. It's just, it took forever to get my doctor to go to the right website for my glucose levels. My glucose levels are publicly available at cgmdatabot.herokuapp.com. There's a command somewhere in the chat for actually pulling that up. You can take a look at how awful I'm doing managing my diabetes. But the thing is, since I've gotten automation, it's been, my A1Cs have just been the same number every single visit, which is great. I bet your screws are with my earbuds. Yeah, they probably are. That's in the cat dimension. So at the doctor's appointment, the doctor was entering the URL, but I don't think he was typing HTTPS, and I think the browser was putting something ahead of that site. And so what they would do is they would either open up Heroku app, like the login site, or you know, some other thing. It wasn't opening up this page because they just wouldn't enter it properly. So I had to actually email them a link. It took forever to figure out. I don't know why, because he's dealt with patients that are using the system, so I don't understand why it was so difficult to pull up a website that wasn't a normal sort of formatted website. It's more of a database with a front end. But yeah, if I did like a URL shortener, a shady link generator, but those are often tricky too. Those don't have typical like W's and stuff in them. I don't know. Either way, whatever I did worked. I linked him to it, and he clicked on it properly and actually went to it. But it's tough when somebody doesn't know that all of the conventions that have been invented around hypertext transfer on the internet are bucked, because this thing is not a typical website. It's a database with a front end. It's you know, like baked into phones that they'll add stuff to the URL in the phone. So it's like, I don't know how to direct this person. How's it going, Akreta Mike? I spray painted something in here, so I'm dealing with all the fumes right now. There's a bit of a chemical twinge to the air right now. I shouldn't have sprayed something in here, but I did. I get to test how good my airflow is. The big book. Let me go get the big book. I know, I wanted to try out the spray paint that Wexo sent in a million years ago, and I sprayed out of order. I shouldn't have used the silver stuff. I should have started with matte black, masked off all of the little matte black features on the car body, then done silver, and then on top of the silver do the orange stuff that makes it orange. So I'll probably reprint that car body at some point. I have to get the scale right too. I think it's like 97, 96% scale so that it'll fit the RC car. My only problem is with the 3D model that I got, the wheel wells have been super duper enormousized. They made the wheel wells much larger, the whatever the trim is. And so the RC car wheels of the good RC car are too small in that thing. My fasting blood sugar was 5.6, which is 100. My latest blood test, my doctor was really happy with me yesterday. That is a good number to have. Yeah, and fasting, so that's sort of your body regulating yourself, and it's getting it just right. That's just about the middle of the limit, the 80 to 180. But yeah, so I've got some problems with that 3D model, and I tried to look up other Lancia Delta car bodies, because I really like the Lancia Delta. I'm a hot hatch fanatic. I liked my hot hatches back in the day, and this one is very pleasantly square. And I was hoping that I could get a Lancia Delta with smaller wheel wells, but that led me to 3D Cult's website, and the 3D Cult's website, you know, I know a lot of effort goes into making a 3D model and stuff, and I know it's good to pay people for the work that they do, but 3D Cult's, whatever the hell that website is specifically called, they want like $10, $15 for a shell model of a Lancia Delta. And I think they're all getting the original 3D model from the same place. They're just gutting it differently, which is a little bit, I don't know, I don't like it. So I couldn't really find a free one. I was hoping to find the original model, but I think somewhere out there is a 3D model of a Lancia Delta. There's also whatever that other Lancia is with that sloping back and the very square front is like one of the most perfect looking cars. And I would love to do that one for the RC car body, because that one is a lot lower to the ground. But the hot hatch would allow me to put the GPS speedometer inside of the thing, so I could give you guys an actual impression of how fast that thing is going, because that RC car is fast. Another thing that I want to do is, and I'm still 3D modeling the parts for this thing. On the Atomic RC car, the parts for the RC car are the most over-engineered things I've ever seen. They're cut out of aluminum. They're very small parts. They're not necessarily fragile, but they're very small parts. And they have been chamfered and filleted to a degree where I'm actually having to reverse engineer. No, the RC car with a knife would fucking kill me. That would murder me. I don't think you want your intrepid host to be murdered by an RC car. Maybe you do. Maybe you should see somebody about that. But I'm not going to do that. Multiplex decoder without mute. Ooh. I see serving on a stereo demodulator, 19 kilohertz amplifier, and double and stereo indicator lamp driver. Supplies 12 volts. Gives IC. What the heck is this thing? They just drew a whole goddamn chip. How's things going? I could use a little bit more time for everything. A lot of my free time right now has been spent uploading files, uploading big files, and I think YouTube is rate limiting me because it updates very, very slowly. The upload is slow. And so it's this whole process where I have to spend half an hour to an hour on every single video, putting notes in it, making a thumbnail, putting it up, getting a title, putting it in a coherent playlist. It's been a lot, and I can do about 3 per day on an open day. I did 3, maybe 4 yesterday. I think it was 3, until I'm just dead sick of looking at myself, right? And I've been keeping up with that. We started at 350 to upload, and now I'm at 140 something, 142, I think, left to upload in this directory. It's my entire 6 terabyte hard drive, which I'm thinking about splitting off 2 hard drives from that. If I don't want to order old hard drives though. If I pick hard drives out of my server, I could fill the 4 terabyte with the data on the 6 terabyte, retire the drive, put a 6 terabyte in the file server, bolster my file server, make it a little bit larger. I got to work on all of that. It's just I got too much on my mind, right? Did a doctor's appointment yesterday. My dog is gone. She's gone. Where is she? She's gone. She's gone to my brother's with my folks. So I am here alone today. I don't have any responsibilities except to, I don't know, wake up in the morning so I don't die. And we're gonna work on a big book of circuit, and then who knows where the afternoon takes us. Burn the Subs needs work. Hajiwo's code needs a complete rewrite from the bottom up. I've been working on Hajiwo's rewrite. It's the same thing I went through with the VCO, where he's done a few things that buckle up against the death by sleeping. I wish, man. I wake up in pain. I rolled over onto the insulin pump, and I was like, okay, ow. So my sleep just gets interrupted as a diabetic. Maybe I'll sleep a little better tonight if I can go to bed at a normal time. It's like I'm in a house with morning people, and I'm an evening person, so I know which individual floorboards squeak and how to move from floor to floor silently, like a ninja. And the other people don't. They wake up and they bang 2 pots together, and then they start slamming the washer dryer door, and then they slam doors, and they punch the wall a bunch of times, like, good morning, the sun's up, and I've gone to bed at 3 a.m. and it's only a couple hours later, and I'm like, what is happening? Why am I awake right now? I don't understand morning people, why they have to make it everybody else's problem, and yet night people are required to tiptoe. Sucks. But anyway, yeah, I'm just trying to get ahead of everything right now. There's a lot going on, unfortunately. For somebody who doesn't have a fucking real job, I've got a lot going on. I don't know when that happened. Some other people no longer, well, whatever. It used to be at noon, everybody would come out of the woodwork because everybody was on lunch break and they wanted to communicate with you. And I've systemically trained those people not to contact me at noon. So anyway, yeah, a lot too much stuff going on, but we'll get through it. Dave's synthesizer, I need to take a look at too. I need to start reverse engineering that like in a serious way. We've got a couple of the parts sort of cornered out, but we don't know what exactly is not working. Oh yeah, start soon isn't up. I'm gonna get a glass of water. I'm gonna get nice water from upstairs. I'll be right back. I'll put up a BRB. It's our new project. Sounds interesting. Oh, I'll check it on the Discord later, yeah. Upstairs water. Yeah, this is filtered and it's stored in the fridge before, like it goes to a bunch of pipes in the fridge walls, and then it goes to the filter. So this is cold and filtered. Look at how hot it makes everything else seem. You don't have to recount that stuff, the stupid comments that I make. A lot of cool stuff in here. I'm hoping we can make a couple Fridays out of this, because there's a lot of weird stuff. I'm hoping it gets, like, weird. I'm hoping we find some weird stuff, but for now, we'll stick to the fish noise. Oh, yeah, I gotta figure out what I'm doing. I guess I kind of know what I'm doing. Everything is planned, I just need to do it. I need to do all those uploads and stuff. That's the tough part. I got a LAN party tomorrow if the solar flare doesn't kill us all. Bro, make the fish noise before the solar flare kills us all. I'm changing the title. I'm changing the title on Twitch at least. Bro. Make the fish noise before the solar flare kills us all. Exclamation point. Done. That's a good title. Bro, make the fish noise before the solar flare kills us all. We got a big ass solar flare that's hitting the Northeast, and it's possible that I would be able to see it, although it's tonight and it's overcast as hell, like rain is moving through the area, so it might not be able to do, like, see any of the sky and see the northern lights. It'd be cool if we did. No, I don't need 1960s parts for these things. These are squarely in the 1970s. There are some vacuum tubes in a few of these circuits, more than a few of these circuits, and although I do have vacuum tubes, I doubt they're going to be the same ones that are called for in these. You imagine being a fan of electronics back in the 70s? Some of you don't have to imagine, I'm sure. But you sit there and you get a magazine in the mail and you go, oh, fish noise. What parts do I need to make the fish noise? Probably need more adenoids on that impression, but still. Oh, the fish noise. That sounds like a proper project. I can't do British accents very well. Every now and then I'll do a brilliant British accent, but if I'm not saying the right thing, it just doesn't come through. I should have gotten to voice acting. I think we're close to the fish noise on this one. There it is. That's the circuit we gotta make. We'll find it again later. You see, with all these measurement circuits, it's like it's not hard to measure stuff. It's all we do in electronics is measure stuff. The measuring stuff is complicated because of the calibration. You got to make everything work in concert with itself and give you, like, consistent results. Like, you know, whatever. That's why I buy my measurement stuff instead of building it. I'm sure some of these can be specialized, but, like, shouldn't we... Like, measuring power is not something that I would trust to a device that I built myself. Humidity control? Oh, wait, these are indicators? What are these? Ooh, that feel of the page right there set my teeth on edge. What was that all about? No, you don't. No. If you buy, like, a nice oscilloscope, do not calibrate it yourself. It'll come with certificates of calibration from things that are more sensitive than what you can do. If you buy it, you can compare it to the equipment that you have, but you really should not be calibrating your own equipment. That's why you spend all the big bucks on measurement equipment, so that you have a certification that's not you. What are you looking at? This is a big book of circuits. This is my big damn book of The Big Book, the Guidebook of Electronic Circuits, 1974. There are more modern ones of these. This one's just from 74, which is awesome. RF admittance bridge can be used for measuring 10 to 1000 ohm RF resistance, 0 to 500 picofarad capacitors and inductance, blah, 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 blah. Yeah, it's like, why would you... Hydrometer? So that would be for how wet things are, but it looks like you plug it into the wall. I'd rather not plug that into the wall. Something that's measuring how wet soil is not something that I would want to plug in the wall. You guys give me no credit for being able to run my own stream. I've been streaming for like way more than 5 years. I know what I'm doing. Every now and then I'll leave something up by accident, but why do you gotta always mention? Somebody's always gotta come in and mention this. We're not building the fish noise maker right now. We're just chewing the shit and making sure that enough people come in that I don't have idiots telling me what I should be doing or asking what I'm doing. That's how this works. The collective dumbness of all of us is stronger than a single dumbass. And so we wait for that collectiveness to build up. It's like a coil gun. We got to charge the capacitors first, and then we can electrocute ourselves. Speaking of medical circuits. Could you imagine if like electric chair was just one of these? It's like, oh, build your own electric chair. I don't know. We're going to find out what kind of noise fish makes. That's the fun of building a fish noise maker. We got to do it before the solar flare hits. That's tonight. That solar flare is coming for us tonight. It's going to fucking bust the door down and eat our data. Yeah, I don't like publicly executing the people watching my stream, but I have to, otherwise I will be asked every second of every day why I have something up on stream. Why is your microphone unmuted, bother? Like, blood pump drive. We've already looked at medical circuits. Look at something different. Radar circuits. Do they have the radar detector that police have? Because a radar detector is going to have an internal oscillator, and that internal oscillator can be picked up by an external device. And so if you have an external device that picks up the internal oscillator specific to police radar frequencies, then you have a radar detector. And you can keep going down that spiral, at least until the radar detectors put some actual shielding on their circuits. My hands are dry. This book is sucking all the moisture out of me like a salt vampire. Schmidt drive for counter. Tripler. Radar speed meter. What the fuck? Wait, but that's like nothing. It's a little Zener diode circuit. Wait, this is nothing. This is part of a much larger... What is this? Is there a flare called Solar Nightmare? So this is not the circuit that I was just talking about. In fact, this, oh God, I can't position this thing. Hold on. This is supposedly, no, that's not it. This is it. So you have 6 volts, you have a 5.1 volt Zener diode, 1.5K there limiting the current. You have your output and ground, and then you have your input. This is just a switching transistor with a bunch of diodes protecting it. This is the dumbest thing I've ever seen. This is not a radar speed meter. Capacitance coupled amplifier provides limiting when the signal source exceeds the value determined by the input voltage Zener. When you reach 5.1, it switches. A BC109. It's whatever the engineer decided at the time would suit them the best. It's funny, I planned this stream. This is not influenced by Uo's robotic fishing endeavors. I planned this beforehand. Here are my notes, which are on a package full of SPI screens. Do the fish noise next Friday. And this is 2 Fridays ago because I missed last Friday. We're taking out the big 1974 circuits book, and I have to make the fish noise before the solar flare kills us all. I was spray painting down here just a minute ago, and I'm loopy with the fumes. I went to the stairwell over there to get water, and apparently all the fumes have collected in the stairwell. There are other open windows in this house, I think, so I shouldn't die much. But yeah, I'm all inundated with spray paint fumes right now. But yeah, inside the big book of circuits, we found the fish noise maker. It is not a complicated circuit. It's not going to take us a long time to do. So after we make the fish noise before the solar flare kills us all, I will have to figure out what else we're doing today. It's not like I don't have a lack of anything to do. In the background, I've been programming all my time. I made that years ago. What, the fishing bot? Oh, okay. Look, I get whatever the Twitter algorithm deigns relevant to my interests, which is fucking anything from any time, any place. I saw you were doing a controller project with the big child's controller. The closest I've gotten to doing that, I bought that 2-player controller. Where is that thing? I still have it in a bin somewhere over here. It's the one that you were always given at a friend's house that had soda stains, and so wasn't really functioning properly. But what it had was a touchpad. And since on a touchpad, you don't have a pivoted D-pad. You don't have a pivoted D-pad on a touchpad. It's in here somewhere. Rest assured, the Mad Catz Player 2 controller resides somewhere in here. But because you have a touchpad, you can hit up and down at the same time. And that's a big problem for the Nintendo, because if you hit up and down at the same time, it'll cause glitches. It's actually a speedrunning strat in some way. But yeah, the Mad Catz with all the turbo buttons, the way that Mad Catz kept you from hitting up and down at the same time, 7400 series logic circuits. So just like the original Super Nintendo was, and I think Super Nintendo and Nintendo were just shift registers. That's why it had 5 pins, because it was power, ground, latch, clock, I don't know, chip select. I don't know what they all exactly were, but it was 5 pins that were exactly just interfacing with a chip. They didn't think to serialize it at all. So they would latch the inputs, read them back well, that is serializing it. Latch the inputs, read them back. Latch the inputs, read them back. And it was able to do that very quickly. But the Mad Catz kept you from hitting up and down at the same time with just simple logic circuits. So the up and down would go into like an AND gate with something, or like a XOR or something like that. Pretty cool. And then was it a 555? I'm trying to remember how Turbo did its job. Turbo did its job. I don't know if it was with an RC, or because if it was with an RC, you could do some hilarious things by putting the controller in a hot room. But I don't remember how it did that. I should find that. It's in the bins over there. I just don't want to put my butt on camera for that long. Fuck it, I'll find it. I'll find it. It's over here. It's over here somewhere. Yeah, I've been doing nothing but rewriting code, so in order to get myself to not lose all sense of self and purpose, I am going to work on one of these 1975, 1974 circuits. Just building it. It's just very simple to build. And we'll see if we can find something else that's cool to do. Because I know it's not going to take all of our time today. I could really draw out the breadboarding. I could really draw it out. There's like a missing bins. What's going on here? A bunch of antennas I could use. All right, I don't know where it went. Keyboard keys, what the heck's that doing there? Wait, what's that one? That one's vacuum tubes. Oh God, like all these bins have been like unseated. Unseated. Some of these like vaguely back. There's my screens. No, 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 no. Oh, wait, you know what? I probably put it back together. I might have put it back together. It might be up there. Never mind. For a little while when I was streaming, what I would do on Fridays is we would do teardowns. And so I'd take gaming stuff that I've just accumulated over the years, take it apart and figure out what makes it tick. And we found some very interesting stuff. Like I went out to Micro Center and I bought a bargain bin. Yeah, they're little sewing, translucent sewing cases. I think I got it at Michael's a million years ago, but they're really good for storing like just little projects in. But yeah, so I went out and I bought at Micro Center, because all my life I've lived kind of near a Micro Center. I'm a little further away from it now, but it's still totally an afternoon that I could just go to Micro Center and wander the halls, the gilded halls of computer stuff. So in the bargain bin, they had this German Wii controller that could also work on the PC. I was like, okay, cool, let's take it apart and see what we got. And there's always something interesting doing that. In this case, we actually found the turbo button had been, I guess, subject to time crunch. And so it actually said tub bro. And so for a while, that was a thing on this channel, the tub bro. Bro, what are you doing in the tub? But the controller buttons for the triggers were separated, just push buttons, because I guess Nintendo's never had an analog shoulder. So I don't know why people play racing games on Nintendo products. They've never had an analog shoulder button. So there were these big rubbly buttons. I pivoted on that, and when it came time, I identify as Tub Bro. I was imagining Scrubs, where his brother's grieving and he's sitting in a tub and he just has beers. He's drinking the beers, and they're like, "What's the ratio of piss to water by now?" And he's like, "I don't know. It's shifted. It's tilted towards one end at this point." Anyway, so the Tub Bro button was perfect for taking into AutoCAD and turning into a desktop thumb button. And the desktop thumb button was for Tom Thinks. So Tom Thinks of Burb fame, well, you can check out Tom Thinks' Twitch stream. He's quite famous. He became the face of Twitch ads for a little bit because his style is particular. And I think Tomato particularly hates his global emote, which is the white box with the face in the middle, because Tom does everything on a white background. So he actually puppeteers drawings through Flash and the actual professional version of Flash. And I think he's been migrating the technology to something new. He mentioned it last time he was in here, but I was too, streamy to really pick up on anything. What up, Poopsie Doodle? But yeah, so we built that for him because Tom stands at a desk. Well, professional Flash is totally different, right? He uses it as a programming method of on-screen animation. So he's able to trigger different phenomes, I guess they're called, of mouth movements so that he can puppeteer a mouth that looks like it's talking by playing the keyboard like a piano. It's very cool stuff. It really does a great deal towards making comedic drawings on, like little sketch drawings on Twitch. Flash is my favorite malware. My senior design project, my capstone project for college, involved animating Adobe Flash. We had a dancer on stage that we had to track, and then letters would fall from the sky and bounce off of the umbrella and the dancer. The cool thing about that is that it's fucking rain. It's just visual noise. So some of them can go behind, some of them can bounce off, some of them can bounce off of something in a totally different part of the screen. It still looks like things are bouncing off stuff during a rainstorm. So that was a weird project, but we did quite well. The professor thought he was giving us the biggest incentive we ever had by saying, "Guys, you can go to the after party with dancers. You can party with dancers at the end of this. There's like all the motivation you'll ever need." He had us coming in after we graduated in order to run that, which we did. We faithfully followed his word, and then we went and partied with dancers. And as somebody who knows theater kids, I'm like, that's not going to be everything that's cracked up to be. Like the other engineers were like, "Whoa, we get to go to a party with like the theater guys," and I'm like, little do you know, guys, it's not going to be anything you think it's going to be. But yeah, so the Tom Thinks thing was perfect for me because it was an orthopedic. Calling it orthopedic, it makes it sound like Tom is a million years old. He's had like a bad ankle, and so standing at a desk and operating a foot pedal, his feet were just not in a good place with a foot pedal. So instead, we took it up to the desk by 3D printing an entire button carrier with an actual rubbly button. So that was the one collaboration that I've been able to just knock straight out of the park and do like the perfect project with. Still chasing that dragon. I'm still chasing that dragon. If I could find something that I can help somebody out with in a similar manner, that would be amazing. But yeah. I should also probably find people who watch my stream that want to hack into microcontrollers, because these Omnipods that I use, I'm like burning Omnipods, right? I use one every other day, every couple days, if I inject I know a person. So with the Omnipods, they have a particular microcontroller in them that does Bluetooth, and I would love to be able to get into that and throw code in there, because then I've got a pretty powerful microcontroller that I can put in everything. That's and then over time I generate more. I just uploaded a couple videos that had to do with that. If you know a person, I know we're in each other's whatchamacallits pants. You can just PM me. Or I'll PM you, or maybe I'll forget again. That's how it always happens. Why are we taking pictures of stuff? These are weird. You gotta make the fish noise. The solar flare is coming tonight for us all. In North America, nowhere else really matters. Oh, I just found the piano reel of the song. Yep, that's it right there. I'm trying to help build an accessibility thing for someone, but I haven't had the time to work on it. I'll hear about it. I'll hear about it. I just got done talking about how stupid busy everything has been, but I'll definitely listen to it and see if it'll be a quick thing that I can do. I'm spread a little bit too thin right now until I'm done uploading videos. That's my problem. That's a problem that I've created for myself, but I mean, self problems, welcome to my world. I've been uploading daily for YouTube, which is like crack to YouTube algorithm. The algorithm loves it, but I've gotten this close to not doing a daily upload. I was only on the day where my next upload was the next day, and I've still got 140 to upload. I'm roughing about 3 a day when I've got a free day, but I haven't had a ton of free day. I had doctor's appointments, stuff that I had to do. So there's been a lot of craziness, and I wish I could get like a month ahead. I really do. It seems like I got 150 days to go, though. Hey, what's up, Cluck J? If only you knew somebody who knew Omnipod hackers. They know the Bluetooth low energy signal that goes over the air that's known because it's got a standardized, it's got a PDF that's 1 billion pages, and medical devices are in there. Have they done a microcontroller takeover on the Dash? Because I'm generating Dash chips like, I've thrown away a couple in the recent past, which I feel bad about. But I've been cracking them open, and I've got bins, like a bin of electronics bin that's full of the microcontroller. And I could probably get it onto its own PCB, or I could probably try to set something up. I was talking to PyroEsp about it a little bit recently. I've got all the programming stuff to do it. I just want to know what I need to do to set up the environment and stuff, because I think that could be a very interesting thing to like put on a breakout board and just throw my own code at it. And then we would have like an Arduino style platform. If I could put an Arduino bootloader on it, that'd be hilarious. But it would be like a Pico Pi style. Yes, I've seen the X-ray hack, and that was actually something near and dear to me a while back. People thought, oh, Bother messes with electronics. Maybe he can get this $20,000 bounty on actually getting a hex file off of an Omnipod. The way they ended up doing it was a couple researchers actually they boiled away with acid. They boiled away the substrate of the microcontroller, and they visually observed on a microscope the ones and zeros in the data storage portion of the microcontroller. And so they were able to observe the gates, the silicon gates, and using MATLAB, they were able to take like a statistical view of a bunch of them and get ones and zeros. So the hex file was just laid out for them visually by physically looking at memory storage devices. Pretty crazy stuff. It's pretty crazy stuff. They did a really good job of breaking down how the Omnipod worked and stuff. Now I was, in a previous life, getting the code off of microcontrollers was something that an external lab did. We didn't quite do it. We didn't look at the software, but I knew guys who did that because that was one of the processes that the devices went through. It's getting the code off of the chips. We didn't do that specifically, but we were knowledgeable in a lot of stuff like that. So it was like, yeah, I could totally try to take a hack at this problem. Now, it turns out universities are just way better equipped than I am to do that kind of smart boy stuff. The way that they broke, this isn't Omnipod related. This is actually just Keylock, Keeloq, is a very interesting 2 lines of code that sold for $1 million back in the day. Could you imagine? I made 2 lines of code, and they encrypt and decrypt signals over the air. And then all the car companies are like, And then Microchip comes in and goes, hey, you want $1 million? Like, yeah, for 2 lines of code? Cheers. What Keylock does is it does 256 rounds, and it scrambles a private key and a public key together. So all the car companies came up with their own public key. There was a private key, and then I think there's another key on top of that too. But they are just used in order to scramble a code. So it's like a book encryption, where you each have a book, and you go to a particular page of the book, and then you decrypt on that page of the book. And it has signal rounds, and it has lockout rounds. So there's a portion of code that'll wrap around, and as long as you're within a window of that code pertaining to the last code, it will allow you to do stuff. If you're within another window, it will allow you to press the button once, update itself to that round, and then you press it again, and it unlocks. So there's like a big time lockout or number of code lockout. So what you can do is, if you know key lock, you can lock somebody out of their car, and they'll have to hit the remote more times than you have time for in the next 7 years until it unlocks again. It's a weird system. It's a lot to wrap your brain around. I meant to have a big stream where I talked about that encryption, because I think it's very interesting. But that key lock was broken by researchers observing the microcontroller passing 1s and 0s to and from its instructions. So a microcontroller will take those machine language lines of instructions, and it'll say, like, move a bit here, or put this one into the math coprocessor. So it'll do that, move the 1s and 0s around. And what the researchers did was they hooked a resistor up to the power supply, like a 1 kilo ohm resistor up to the power supply, and then observed the current on an oscilloscope. And they saw where 1s and 0s were being taken and left. And it's like, what the fuck? So they did that, and then they were able to figure out what the private key was for Keylock, and that made the entirety of Keylock insecure. Researchers are crazy. You don't want to mess with them. Encryption people. Trying to hack some Govy Light controllers. The package looks a lot like an ESP8266. Are you looking at Tasmota? Because Tasmota will function on the ESP8266. So if your chip is in fact 8266 or a knockoff, you can check out what the pinout is, do a little bit of circuit level reverse engineering, figure out what pins are doing what, and then make a Tasmota system do it. Yeah, it's pretty crazy. You hook a resistor up to a microcontroller, you're like, I can see it thinking. and I didn't buy one. I should have bought one, because some shady retailers from a certain region of the planet were making devices, digital devices, where you had a little screen on it, and you would hit the brand of car, and then you could do an over-the-air listen for the keylock signal being sent, and it would automatically know what round it's on. It would know, how to send the signal. So you would just get their own cars or manufacturer's private key over the air, and then you were able to just unlock somebody else's car. It's like, oh, and you could keep them from unlocking their own car by advancing the rounds in a certain way. So you could keep them from opening their car, and they go, I gotta call the car company. And when they go back into their house, you just unlock the car and leave with it. Especially in the days of keyless starters. I'm not sure about those, but you need some more digital tools in order to successfully steal a car like that. Maybe you then get your buddy to tow the car and put it in a container truck. Security is crazy. All right, maybe we should get started, huh? It's Friday, it's raining, it's like an awful day. It's cold in here, which makes me more comfortable because I'm a fat ass. Let's get this out of here. Let's get 2070, 20x80. Who the hell? Who is this? What is this? Where am I right now? Who this? Let's see, who is this? Mega Drive by 198XAD. Oh no, 19X8D, 198XAD, I think is the album, but the artist is Mega Drive. Pretty cool. Pretty cool. Just using it as background music. YouTube can't hear this. Nobody's watching on YouTube anyway. I don't know. I don't have any viewers. They've all left. They've all left for greener pastures. They're at a farm somewhere. What are we doing today? Well, we're fishing. I have to make the fish noise. I have to make the fish noise. We need to find out what the fish noise is. Bro, are you making the fish noise right now? I don't know. I've never heard the fish noise. I don't know if I'm making the fish noise. I'm going to make the fish noise. I'm going to do it. I'm going to do it. Nobody can stop me. The only thing that can stop me from making the fish noise is the solar flare. We have a big solar flare hitting the Northeast tonight. It is super duper duper cloudy out, so I don't know if I'll be able to see northern lights in the sky. That would be pretty cool. I don't think any of my diabetes stuff is going to go tits up. I don't think I'm going to lose anything like that. What the fish? I don't know. I don't think anything bad is going to happen necessarily. A couple data centers might have a hard time. Do fish have ears? Either way, we're going to make the fish noise. It's our duty to make the fish noise. We have to make the fish noise. We have to make the fish noise. The fish noise is something that came out of the hobby section of my big book of circuits. We're going to do a couple Fridays with this big book of circuits. Big book of circuits is my big effing tome of electronical circuits. This thing is as close to a wizard's tome as you can get in this modern world. We're doing things using runes that have been arranged in a particular way that code functionality. It is modern day alchemy and magic that we are doing here. We're using eclectic objects that are found within the world. Sometimes they're scrounged from ancient things, following the runes, imbuing them with power, and getting mystic functionality out of them. This shit fucking rules when you frame it like that. The Electronomicon. Hell yeah. Yeah, this is my big circuit book. What this is, a Bridgewater with a fucking book of his own. Oh God, here we go. Hang on, I gotta read this with no emotion. Two young fish were swimming along, and an older fish swam past them saying, "Hey boys, how's the water?" A minute later, one of the young fish turned to the other and asked, "What's water?" Thanks for coming, everybody. Anyway, before that horrible joke took the wind out of my sails, thank you for subbing for 44 months. I appreciate it. Yeah, so anyway, we've got this big tome of circuits. This thing is the Guidebook of Electronic Circuits by Marcus, published in 1970. It's like 4 is what I think it is. 1970. Yeah, 74. Remember the Dewey Decimal System? I don't. Anyway, this thing was published in 1974, so all these circuits are from previous. We are not going to find any, maybe a little bit. Well, the thing is, this was published in 1974, and the 7400 series, is 74 denoting the year that the 7400 series circuits, logic circuits, came out? We see a lot of comparators in here. We don't see a lot of logic circuits in here. I think there might be 1 or 2, but this is a book that predates logic circuits. It's that old. That's cool. So, we were scrolling through this, I think 2 weeks ago. I missed last Friday. And it was a couple weeks ago. We pulled this thing out and we started looking through the circuits. And then I tried to do an audio-related circuit that I thought would be very interesting. And it turns out that some of the circuits in here, and one of the ones that we were looking at previously, some of the circuits in here, previous today, like during the intro, some of these reference individual tiny parts of a whole. So if you have an IEEE article about triggering a particular thing on a larger device, they'll have this cute little circuit that looks nice and simple, but it's actually hooked up to like a huge system like this. This one has logic gates in it. That we've run into, and we ran into it last time we tried to do this. So this series of me going through this giant freaking book that I found and getting content out of it, it's like some people in chat looked it up, and this type of book is worth like $300. This is like not a cheap fucking book. But me trying to get a little bit of value out of this book has not gone very well, because the circuit that we found was a tiny piece of a very large hole. Not my very large hole. I mean like a hole, like WHOLE. I mean, it's like a part of a huge circuit that's vastly complicated and has a bunch of different weird things about it that you would have to put together and would make it infinitely harder for me to put together during a stream. It's hard enough. It's hard enough doing stuff that I have the parts for, but doing stuff like this where they pull a random part out of the sky and go, hey, do you have this specific LM918874? And I look it up, and the company is like, well, the company got sold like 4 times, and now it's part of Microchip, and we haven't made that since the 70s. So good luck. Good luck. Here's an equivalent that doesn't do the same thing. And all of this information is buried under Google, which has become utter nonsense in the past couple, like, decades. The past 5 to 8 years, Google's become utterly fucking incompetent, and it hurts me because I'm unable to do the type of searches where I find parts and equivalents with confidence. So we need a new tool, and it's not AI. It's not AI. We need a new tool. Eventually I'll figure that out. Maybe we can like limit the website by, does one of the Googling tools limit the website to being before a certain year? That would help. Yeah, when it was a useful tool. There's also, you can tell it to follow the letter of the word for your search. And I think that also kind of tunes it up a little bit from what it used to be, from what it is now, from the uselessness of it now. But anyway, we tried to look up one of these circuits last time, and it was one of these ones that was a tiny part of a whole. Even during the intro, we had a circuit, and all it was a transistor switch. And it's like, I'm like, wait a sec, I know what that circuit is. It's just a transistor switch. But the book framed it as being a radar gun. It's, a speed triggered radar gun. And it's like, well, you have to hook it up to something that's measuring the speed and turning it into a voltage level. None of that was in the circuit. It was literally just the 6-volt trigger. Find all the old electronics forums and book them all. I don't trust forums. Listen, I actually like Reddit in that relevant stuff floats to the top. So if you got people trying to solve something in electronics, you know, there's a lot of other facets of that particular method of organizing things that is terrible. But when you have something like a problem with something, or you want a review of something, relevance up to the top, it percolates up to the top. That saves me a hell of a lot of time interpreting individual answers. You don't have to sift through as much, bro, you're stupid. You can actually just find out what you need. Now it's just an advertising shotgun. Yeah. Well, maybe the enshittification will go far enough that it kind of circles back, and people. There's not much backlash nowadays. They've kind of taken the consumer out of the entire equation. We're just a statistical amount of eyeballs for things. Anyway, not to be too doomery and pessimistic. I'm trying to be optimistic, chat. We've got the circuit book from 1974. So this stuff predates, to a degree, the 7400 series logic gates. It predates digital electronics. There's a lot of stuff in here that's unsafe. A lot of, hey, Timmy, plug that into the wall and have another cigarette. Like, it's ridiculous. So let's take a look at the fish noise. Now, the fish noise is so burnt into our collective consciousnesses that I only need to flip this a couple times before we actually find the circuit that we were looking at. The pages are like creased or something. I don't understand. So in the hobby section, well, maybe I do need to look up the hobby section. I randomly flipped to the fish circuit earlier. I was like, wait, we got to come back to that. The fish noise maker. Yeah, let's look up. So, all right, we start with the index. What's up, Mahalo? I like going to audiophile forums and laughing at the people who spend thousands of dollars on a box built with a $3 DAC. That's why whenever I talk about audio stuff, and you guys might not notice it, whenever I talk about audio stuff in particular, it is a minefield. You have to be very careful with audio people because there's a large amount of sort of pocketbook bias. There's a lot of justifying your purchases on there, and you've got to be careful around that. Now, for me, my whole justification of purchases revolves around vacuum tubes. I hated vacuum tubes. You know what? Transistors can do everything vacuum tubes can do and more. You can tune the transistor to act like a vacuum tube at its harsher frequencies. Well, I mean, maybe a lot of things that I was listening to at the time didn't do that, but I bought from Shit Audio, SCHIIT, I bought a vacuum tube amp so that I could say definitively that vacuum tubes are sucks. They're not. I had my entire opinion upended on itself. The difference in the physics, the difference in the way that the electrical signal is being handled, and it's not some romanticizing about a glass tube that's been heated up with a little 60-volt heater. Just something about the way that it's able to handle audio makes a lot of the high-frequency stuff less harsh. Now, I use that as a pivotal thing to alter my audio. A lot of my audio reproduction systems are one-for-one kind of things. You know, the audio people will say, that is it's very robotic. The sound that makes is very robotic. It's just a one-for-one reproduction. I'm like, yeah, I want to hear what the guy who mixed it hears. I want that. So that's sort of my philosophy. Then the only thing altering the audio is the tube amp. So with the tube amp in there, turning up the volume on something feels like you're walking closer to the guy running the big mixer at a concert. It just feels, it's louder, but it's not like hurting. It's a very interesting phenomenon. I am now forever an advocate of tubes. So, but the thing is, when you're talking to audio people about stuff like that, I make sure to say, to me, it sounds better to me if it's doing this. I tried this and I think it sounds great. Putting a digital signal through a gold-plated plug is not necessary. It's not going to improve your audio. And a lot of these snake oil salesmen in that audiophile realm, audio stuff can just get so contentious. So it's better not to wade in. It's better not to wade in. And if you do, you just frame it within your own impressions. Because, boy, people love to argue about stuff. Yellow pages. Books can be ordered. All right, so we need the index. Oh, this is addresses of sources used. Oh, that's kind of cool. What if the quad twisted cold-bladed silver? Yeah, you don't need to spend a ton of money to get good audio. You need to spend a little bit of money, but you don't need to spend tons. Fishing opener here this weekend. Mahala's going to get in trouble for rigging the fish competition. He's going to get best in show or whatever the hell they do with the fishes over there because he made the fish noise. We're going to make the fish noise first. Chat, let's figure it out. Let's get into this book here. We got to make the fish noise. Oh, those are units. Abbreviations used. Useless. We want the index. Contents. Hobby circuits. Need the EFG. Where is that? H. Hobby circuits. 344. What up, Brink? You doing? Got all the usuals here today. 344. Well, we just opened up the 337. This is not going to take us a long time. I just wanted to have fish noise in the title. I benefit from having weird-ass titles. 344. Is this even going to be in the audible frequency range? Steam whistle. Oh, you would not be popular if you built this. A tool magnetizer. They're a good band. Baseball velocity. Massage alarm. Model trains. Slot cars. Fish collar. Electric fence. Drip drip sound. Dice. Fish collar. Fish collar. Motorboat. Toy boat, toy boat, toy boat, toy boat, toy boat. Jesus Christ. And then there's a fish finder. I don't think this thing's going to be finding you a whole lot of fish. This doesn't look ultrasonic or digital at all. Speaker. So are we going to need a transformer for this? This one does not need one. This one does. It's got just like a 1-to-1 transformer. Fish collar, based on a hopeful theory. You know, in technical writing, based on a hopeful theory was the original sentence. They took the A out of there to save space. So hopeful made it in. The adjective that sort of shaves off, or rather sort of colors, it paints a picture of this theory that was left in. That's a significant detail. Hopeful theory that it's basically sarcasm directly from the author. The hopeful theory that fish will be attracted by strange underwater noise. 2 transistor tone generator. All right, what do we need for the circuit? 10 kilo ohm. We're already off to a good start. I've got a 10K that I can dedicate to this. 0.2 oof, 0.02 oof. Okay, I've got those in those yellow capacitors. 3 volts. That's a nice 2N3565. I am going to guess that if I put a 3904 or just a generic transistor in there, that nothing ill will happen. Speaker, a 75 ohm speaker. We'll have to take a look if I have that. We've got that skull speaker thing that we were working on, so otherwise I guess we could take the voltage out and observe it on the oscilloscope. I guess I'll have to pick the stuff off of the Hajiwo build in order to look at that. Yeah, you guys can't see chat at all, can you? There it is. We need 2 10Ks. 2 10Ks. I only have one 10K hooked up to that thing, so maybe we'll just put a new 10K ohm on there. Got a couple things going on there, and then a 2N3565. So what are these doing? It looks like we're pushing back and forth, triggering back and forth. It's probably just an oscillator. Like, is it up, down? No, it's down, down. Huh. Yeah, we're triggering back and forth, and so these caps and resistors are gonna do your timing constants. All right, well, let's look at it. Let's see what it does. Well, 8 ohms is probably what I have, so I don't know if I need to, like, kind of be careful about the voltages on this thing. So when we build circuits like this, we go from runes to actual components. The actual components can be arranged on something that's called a solderless breadboard. So for those of you that don't know anything about that, and I pretty much only see my regulars in chat, so I don't think anybody in chat doesn't know what this thing is. If you don't know what this thing is, you're among friends. This is a very useful tool for this sort of work. A solderless breadboard is a series of clips embedded in plastic, and those clips are made out of just the cheapest metal that you could possibly find. The terminology stems from using actual boards that were for cutting and serving bread in order to mount your electronics with screws. So you had stuff like vacuum tubes would have like a base that had screw holes in it, and you'd screw that down, and then you'd screw terminals with wires coming out of it. You see it a lot when people are trying to be artistic about old school electronics. They'll make a circuit that looks like that, and it'll be very mad scientisty. What's inside of these is a much simpler system. You have a common distance for pins, of 0.1 of an inch between pins, and that's because America invented electronics and the rest of the world is still trying to thank them for it. Everything for the older school electronics is done in English, so we are forced into a 0.1 inch. When you get into surface mount stuff, it actually shifts over to the proper metric system, but unfortunately, old electronics is completely plagued by the English system of measurement. It's just something that you got to learn. You just got to know it. You just got to know it and stop complaining about it all over the internet, because everybody is sick of hearing it. I'm dead sick of hearing about it. So what we have in here are a series of clips, and when you insert a lead wire or a pin wire into that, the little clip is going to pinch it. And from the side, there are 5 clips a row. I just can't tell what's focusing anymore. Anyway, the point is there's 5 of these per row. So you use that in order to wire up your circuit without using solder. Solder's a temporary, permanent solution to wiring stuff up. And it's fun, but this is a lot more malleable, and you can swap stuff in. So we have a larger breadboard, and then there's these horizontal traces that go across the whole thing. These are the bus lines. And the bus lines, at least on this one, are marked with the plus and minus. We can put whatever signal we want on it. You know, it's a free country. This is a sign, not a cop. We can put whatever we want on the bus line. Some of this size of breadboard has a gap in the middle. There would be an extra space between one of the 2 of these things, right? There'd be an extra little space. These run horizontally all the way down, but some of them have a gap in the middle. So you have to be wary of the ones that have the gap in the middle. Those are the most annoying ones, because you then have to bridge that gap in order to make your bus lines go the entire span of the breadboard. And if you want to spread your circuits out, which you really should, because it gives you room to work, being cognizant of that gap is very important. A multimeter can save you quite a bit of time. What is this stuff? This is just gunk. Ew. Ew. Yeah, it's like nacho cheese or something. Ugh. Anywho, so, right. So that's that. So in order to build the circuit temporarily, easily, we're just gonna punch it down into this thing. So now we need to find our parts. And so we took a quick look at what we would need. It turns out we need two 10 kilo ohm potentiometers. So I'm going to gather those. This is a pack of fixed resistors. These are unfortunately lower wattage, which makes them a little bit more ornery on this board. If you could manage to get 1%, which that blue color is an indicator that these are 1%, as well as having an extra band to define more accuracy with the value numbers. If you can manage to get 1% that are a larger wattage than these, they'll have larger leads and you'll have less time pulling your hair out getting circuits to work on these things. Unfortunately for me, I did a sort of a knee-jerk Amazon purchase and I'm stuck with 1 billion of these things. So whatever. Where possible, I like to work in surface mount because it's just so much easier. And also the value of the resistor is written on it instead of coded behind color bands. So, but yeah, then you can buy a jumper kit. And the jumpers used to wire the circuit. Some people, some horrible people who are missing a little piece of their brain, you know, the worm one, use these things, these little jumpers, in order to build an entire circuit. And I think that they have social issues. I think that they are less than human for doing that, because what it does is it produces a big bird's nest out of your circuit. And the circuit works. I'm not going to take that away from them, but you just need to go like this to make it act funny. I appreciate a neat breadboard with stuff down at the surface of the breadboard, making the little turns. You can bend stuff around like a pin tool. You can bend it with a pair of tweezers. You can just make that circuit on the breadboard compact and flat. And that makes it easier, for me at least, to work with, because you don't have to trace a weird wire that you've got in the middle of this big bundle. So that's how I work. I try to keep it neat, and I try to keep things in sort of a logical layout. You will eventually get a feel for it if you do it enough. And you know, you don't need a big book of circuits. This okay, so maybe 20 years later, this is completely usurped by the internet. The internet now has tons of circuits on it, and it's got tons of beginner stuff. And you don't have to open a book from 1974 and build a circuit that makes you plug makes you plug a transformer directly into the wall. Don't do that. Do something digital. Okay, so anyway, let's get started. So what I'm going to need is transistors. Okay, I've got a kit for those. The flux one you should often break easy and don't last as long as the stiff ones. Really, I use these for external hookups. That's generally what I'm doing. I'm on Tinder. I'm looking for a good time. I use these. But for all of the internal stuff, I will use the hard lines. And I've had people talk in chat about having just a big reel of solid conductor breadboard line, and they just cut and strip their own to length, which sounds like it's absolute luxury to do after all the struggles I've had, because these kits, they will have certain jumps, and then there's a big open, like, there's just nothing, and then there's huge jumps. So you'll get all your tiny lengths, nothing mid-length, and then it's all super long. Cheap Chinese breadboards don't make good contact. I prefer the prototype on perf board with lead solder. Some people, the perf board always shuts my brain down. The past couple times that I've tried to use perforated prototyping board, and again, this is where you guys kind of jump beyond the scope of sort of the beginnerness of this all. The beginnerness of it all, this is sort of an intermediary thing that's almost obsolete at this point, is perf boarding. If you've got a very simple setup or you have something that you need to break out the pins for, or if you need something that you can unplug and plug back in later on and it hasn't completely died. What's up, Proteus? You can build it on what's called perforated prototyping board. And this just has 0.1 inch spaced holes that have a little bit of a pad to them, and you can solder stuff down on this and then make the connections as you see fit. course, nowadays you can just build a circuit board for about the same price as it is to buy this stuff. One day there will be a generation that just doesn't know how to use perf board. Perf board's useful beyond just prototyping, though. It actually has quite a few other purposes. Like if you're trying to do something that's not like permanent, you use perf board, or semi-permanent, or sometimes you build the circuit on that thing because you're not going to manufacture a bunch of them. But it's so easy now to just get a printed circuit board that it's almost pointless. We could use instrumentation pots, but these have so many turns. I don't know. I'd rather a knob. I'd rather have a knob. Somewhere in here is transistors. Oh, here they are. Right here. Power transistor kit. So this will probably be good for the speaker thing. Then we need to get a speaker. It's probably over here. But we're keeping it on the breadboard because this is such a simple little circuit that if I were to build the fish noise maker on... What the hell are these? Never seen anything like it before. All right, put this back here. Let's see here. If I were to put it on like a more permanent board, I just don't know what I'd do. That just seems like such a waste. That's the front of the skull. Oh no, part dropped out of it. This skull speaker just plagues me because I couldn't get it right. And I don't know why. I tried the simplest of simple stuff to make this speaker work, and for some reason I just kept messing up. Tried to make it into a cyber skull speaker by putting a bunch of bullshit on the outside, like all the resistors and stuff that would power the speaker, but yeah, this, I don't know where these came from, but somebody definitely copied the save button in order to make these. Oh, it's Sony, so of course it's kind of, yeah, somebody copied the save icon and they made it really complicated for some reason. Lock and load. Actually feels really good. I haven't done that in a long time. It's been like more than 10 years since I've done that. Go hug your floppy drives, people. All right, so this is an it's a 4 ohm speaker. 4 ohm, huh? Hide those in a metal box before the solar flare. Oh my god. That's all right. I'll catch you guys in the wasteland later on. After the solar flare destroys us all. There's nothing on them. They're blank already. How's the speaker magnet going to affect the optical drive of that thing, right? That's what they used to use, right? You used to put these in something called a CDR, and it would write to these the optical discs here that see infrared. You can see infrared through it. You won't be able to see through this, but the camera can. Actually, does it thermals? Yeah, long wave infrared gets through a little bit too. LWIR, look at that. Woo. Woo, woo. I managed to fit Song 2 from Blur on a floppy drive in MP3 form. I'm cooler than you will ever be. Lock and load. All right, so. And I've been heavy metal. Someone make him stop that. No, they're unformatted. All right, so we got a speaker with leads that kind of seem like they're going to break off very soon. It's not like I just soldered. I mean, I soldered these pretty recently. Why are they so bad? We'll probably have to put new wires on this. Maybe I'll put jumper leads on it. This thing is going to absolutely explode. But whatever, we can handle it. All right, so what else do we need? Potentiometers, 2 10Ks. 2 10Ks. 2 10Ks. Let's see. What are you? This is 100K, and it's an audio pot. Now, I could get a 10K from the new ones, because the one I have in the breadboarding thing is 100. And I guess we need to replace it with a 10. So let's, I guess, do that before we do anything else. I don't mean to seem like I'm drawing this out and making it last a whole lot longer than it would if I just built the damn thing, but whatever. Whatever. We have to make the fish noise. The solar flare is surely going to kill us all. And we'll have to live in some kind of a post-digital society a la 1974. Horrible. I guess I want to use the alphas on this. I don't want to use the other types that I have. So I want to use the alphas. I'm going to go to the big DigiKey order that I did where I bought a whole bunch of these things. Where did it go? It was over here. Where'd it go? I had an order, a big case full of oh, here there. So we're going to replace the 100K in the breadboarding thing that we made with a 10K. These are 10K, right? Pot, 10K ohm, yeah. 10K is the more common one. If you have a 100K pot, you're just going to get a lot less current behind the voltage that you're making with a potentiometer. And I don't think there's any particular pitfall to that. I don't think it's that bad, but I supported an NCR point of sale system that used 8-inch floppies. Wait, New California Republic? Is Poopsie Doodle already in Fallout? What's going on here? I thought the solar flare hit tonight. That's when I turn into a ghoul. The only fat ghoul. What's up, smooth skin? Oh, can I say that word yet? I guess I can't say that yet. My knife's on the other desk. Hey, I already made that joke. That's my joke. Get off it. Oh, National Cash Register. Ah, I see. All the point and sale stuff is that one, like, whatever it is, that card reader on the iPad. I thought that was a clever use of an iPad, because all those point of sale machines, their software is just screaming for the sweet release of death. It's the same thing with, like, smart TVs. Have you ever used a smart TV whose operating system hasn't just begged for you to wipe it clean? Like, please kill me. I was not made to do this much. Why am I running advertisements? What's going on? Help me. Something's not right. Please kill me. What is it? Oh, there's like a little tab. Oh, I see. Got to cut around it because of all the tape that's on this thing. You're piggybacking Arnold Schwarzenegger. They didn't see you, like, slink off into the alleyway when he arrived. You jumped inside of the, what was it, the container truck that his little sphere of destruction got. How did they light up the lines of the truck? Do you think they sent somebody around with an oxyacetylene torch to just, like, heat it all up to glowing so that they had that glowing effect when he, How did they do that? Probably reflectors. Everything is reflectors. I know they chucked acid on Arnold to make him smoke. On his jacket, rather. I have to set the background app limit to 4 every time I restart my smart TV. What the hell? All the data mining apps? All right, so we need this, and we need this. I'm going to take these off of the Hajiwo circuit requires me to rewrite the software again. I sort of should have seen this coming a mile away and not done that circuit until I rewrote the code. But instead, I did it backwards again, and so I need to completely rewrite the software in order to get this thing to do its oscilloscope duties. Duty. All right, so the 100K, I'm going to desolder it because I want to keep all of the leads and stuff. I think the easiest way to do a big switch is probably going to be to suck the solder away from it and then crack it away from the circuit board. The auto-sucking solder sucker, why do you keep saying it like that? It does a really good job on releasing potentiometers in circuits. I don't know how it does for them on a breadboard, but to hold the breadboard, perf board, I am going to put it into this vise. This vise is a nice, cheap, precision Palmgren vise. It is a miniature precision vise, and it only costs $600 new, which is ridiculous. It's not something that anyone necessarily should have. There's all kinds of manner of circuit board holders. One of the results of this hobby getting so popular, which I love, by the way, there's a lot of gatekeeping in electronics and programming, and the amalgamation of electronics and programming that is embedded systems. There's a lot of gatekeeping, and all of those people should just be told to suck a fat one or something. I don't know. That's probably, you know, that's more mid 2000s. You can just tell them to fuck off, because like all the gatekeeping in this hobby keeps people from actually doing stuff, right? And the coolest thing about this hobby in the recent years is that people who are not programmers, people who are not electrical engineers, have been doing really cool stuff, right? They've been doing really cool stuff. And they've been building things that we would have never thought of in a million years. So I just, one in particular is the AVR Dude forums, where they are notorious gatekeepers and they're AVR programmers, and they think, well, why the hell are people putting an Arduino to flash an LED? And it's, well, because that's a gateway to a bigger project. Like, who cares? Why use a 555 to flash an LED? It's stupid. Anyway, I have opinions. That's why I'm on Twitch. They're just lower than low. I think what I need to do is just add a lot of solder and just pry this sucker off. I think that's the only way that I'm going to get this. Because it's, if I suck the solder away from the pins, I think there's going to be just a little bit of solder still on there. Can you show how to desolder? Yeah, I'll do a little bit of that while we're doing any old project here in a storm, literally in a storm. It is raining outside. So let's move the big book to the side. When I'm desoldering something, so something is embedded in here and I need to take it off, right? That's the wrong one. Did I just rearrange? I just rearranged my scenes. We'll show this. We might as well. It'll be a good thing to show. Hold on, let me put this back over here and then we'll do this. Okay, here we go. So desoldering. So you have to desolder something. So what I'm doing right now is I'm trying to put it in the vise in order to make it heavier. And when it's heavier, that means that I can maneuver around it and I can poke it with a soldering iron. If you have something that's soldered in and it's got through holes, there are a couple different methods that you can use in order to remove the solder from around the through holes. Now you can think of solder like water. It's like a very viscous water where when you put it around something, it will flow onto it and coat it and sort of wet, quote unquote, it. Learning the feel of that kind of wetting is very important. Yeah, I'll bring the light a little closer up. I'm trying to get it so that you guys can actually see this stuff. There you go. Problem is my hand's shadows are going to get in the way, and this camera's particularly sensitive. So the solder flows around this, the two things that it is coated or tinned, and it's sort of like a fluid substance at that point, right? Now this I can't put in the vise properly. I can't go straight up and down on this one. We have to look at it kind of an isometric view. I have a desoldering station. Yeah, so the alternative to what I'm doing right now would be just using this thing in the corner. That thing right there, kind of peeking around the corner. I don't want to power that up right now, but what that is just a little air pump on a soldering iron, and I would put it up against the pins and it would suck the solder away. There's a couple different methods of removing the solder, and I have all of them. One of them is to use a solder sucker. So what this is just a spring-operated device that has, I mean, what's inside of it is grease, a spring, and then spent solder. So this thing has a little silicone rubber tip, and don't buy a solder sucker that doesn't have a little silicone rubber tip, because the silicone rubber will withstand soldering temperatures, and what this is designed to do is suck very rapidly air from around the joint. So what we can do is, the fact that it's a through-hole device, we can take advantage of that. We can cover over the pin, suck the air through the pin with such force that the solder is going to fly off of those joints and leave a very minimal amount behind. The problem with that is that it does in fact leave a very minimal amount behind. So when you're desoldering, you put the iron up against the pin, you put the sucker up against that to create a seal, and since we've got a disposable silicone rubber tip, we can make a good seal on this one, and then hit the button and it sucks all the solder away. There might be a little bit left in there that would be, you know, between the interface of the two pins, the pin and the via. So you might want to wiggle the pin a little bit and try to get it to break that tension. That's where most of the frustration comes from, is getting it to break that little tiny extra piece of solder. So alternatively, you can take advantage of the fact that the solder wants to coat things. It wants to coat things, and when there's not enough of it to coat everything, I don't know where the, oh, there it is. When there's not enough of it to coat everything, it flows off of things. And so that's what ChemWick does. Solder Wick, and the only brand that I really trust these days is Chemtronics, but Solder Wick is designed to take advantage of the fact that you have a very viscous substance that has surface tension. It's kind of like a billion little pipettes that you're using in order to suck the material away. So on the microscope, where's that one? Oop. You take a look at this stuff, and it's just a wick of copper. We've been braiding copper together for billions of years. I don't really know how long we've been doing that, but I mean, this is like easy peasy. The cost of this stuff has actually skyrocketed, but what you're looking to do here is make sure that there's flux on it and then heat. And so I put the big tip on the soldering iron. All I need to do is introduce this to the pin, and it should wick away possibly more solder than the other one did. Let's actually take a look and see if we can do that. But those two methods are the two methods that I would use. Now, desoldering something like this, where it's got a lot of stuff and it's hard to get into to get the stuff, it might result, I might resort to just heating up all the pins and pulling this thing out and away from the circuit board. And I think that's actually the method that I'm going to use. 100 feet for 46 bucks. Yeah, so look, I'm not looking to dabble in other brands of solder wick. I don't have the time for that. Solder wick can vary greatly, and the ChemWick has worked for me. ChemWick has that little bit of flux component to it, and sometimes you get stuff that doesn't have the flux component to it, and it's very, very frustrating. So I'm just using what I know. The other problem with these is that they are through-hole and plated on both sides. So when I remove the solder from this, the plating at the other side still might not have gotten the heat. So ChemWick is very much visual asthma, and it looks like there's a lot of flux right here. So we'll just do this, and you guys can see it in action. Of course, it's copper, so it transmits heat very, very well indeed. MGM Chemicals. Yeah, brand loyalty is unfortunately a very strong thing. So when you're using solder wick, what you're really supposed to be doing, now some people actually pick apart the solder wick. You can spread it out and make it take in a little bit more solder. But one of the methods is you go up a little bit from where you've previously used the stuff, and then you heat the solder wick through, you heat the pin through the solder wick. So I'm heating everything up at once. And then the real technique is you pull the solder wick along the iron a little bit, and that gives you that extra wicking. Now this isn't as elegant as it could be because I've got a plastic pin sitting right on the other side of it. So I don't really know what I'm going to do here. Like if I just as an example, I can heat both of them up by going crossways on this, and you can see it there sucking away all that solder. And then I would be able to, if I was positioned correctly, I'd be able to move down the wick a little bit as we go. It's kind of like painting. Everything is prep time. But yeah, I'm not really going to get a very complete removal there. So let's add a little bit more solder. Braid without flux. Braid without flux would be useful for bolstering traces that are supposed to carry high current. You can leave the solder mask off of traces, or put a no solder mask thing on it in your CAD program, and then you drop a piece of solder wick on top of the trace and solder it down, and it becomes the mega trace, able to carry multiple amps of current. Yeah, you lose capacity if you separate it too much. Some people swear by it. Now this pin is connected to a large frame, so it is tough to get heat into, which is why I'm using the big tip, but even the big tip seems to be struggling a little bit on it. Sometimes you add solder to remove solder too, but these contacts are also sprung outwards. So what I'm going to do is I'm just going to use the heat up method, but you can see how I'm using both of them. You apply the soldering iron, you know, there's different ways for different operations, but for the solder sucker, I apply the iron straight up to the pin, Give it a little bit of time for the heat to wick in. You can also add a little tacky flux if you really want a crutch to help you out. You want little training wheels on your soldering. So you hold that there for a little bit to make sure that the heat saturates fully, and then you make a seal and suck. And then that hopefully removes everything. Now with this pin, it's sprung outwards, so it's still definitely holding on inside of the VN. There's not much I can do to make it unstick like that. Okay. So hopefully that was beneficial to you. This isn't exactly a great tutorial project. This isn't like the simplest thing to desolder, and so it's harder for me to talk around all the stuff that I'm doing. So this is the third method, which is just simply heating up all of the pins with an excessive amount of solder and pulling the part out. The part's going to actually be quite hot. So I might want to use pliers. Yeah, look at how hot the entire body, because of that bracket under it. This big metal bracket that I'm heating up that's under the potentiometer is just heating up the rest of the thing. So I got to hold this thing steady, make sure this is the right part too. I'm going to hold this thing steady like this, and then force is going to be going this way. Make sure I can pull on it. Ow, it's kind of hot. All right, so heating up basically everybody at once. Oh man, I need pliers for this. I guess I could also pry it out. I could put a tool here. Yeah, that'll be better. Okay, so I'm just going to put a little pressure on the side of the tweezers. And actually, I can do this vertically now, so that'll help me get to the pads a little bit easier. Because I'm just fighting against the circuit board. Okay, so let's add a bunch of solder and then hop from pin to pin on this thing so that I can remove this. I'll focus the camera in just a sec. Bunch of solder. I have to watch my positions too because I don't want to melt the pin headers. And also keep in mind that if I was working alone and I wasn't teaching everything that I'm doing, this would all go a lot faster. But I'm on Twitch, so I gotta stream. I gotta do it for you guys. All right, so I'm putting pressure on that. I just want to hop as quickly as I can from pin to pin. Hold that heat in. Oh my God, I cannot read a paragraph in the middle of soldering. All right, so I'm not prying it correctly. That's not a good angle. I need to find a different angle. And this thing is falling out of the thing. Aha! That was really hot. Oh my God. No, I just can't read a novel right now. Using a board heater before desoldering can help. The board is already warm. The iron doesn't need to be put in as much more heat, which makes less time doing blah, blah, blah. You're not going to need a board heater for a long time when you do stuff like that. The board heater is more of like more professional kind of stuff. People don't just have access to a board heater, you know? An Allen wrench and a candle as a soldering iron to replace a voltage regulator. Damn, that's a pretty good MacGyver fix. Holy shit. I mean, you know, anything's a soldering iron if you try hard enough. All right, so I can just twist that, just pick up the tweezers. No, that's not working. It's hard to get even pressure on the component so that it pulls out straight. And since these are little clips, they're gonna fight me a little bit more. I'm trying to get out of the shadow of the light. The light's putting a huge shadow on everything. Hold on a second. Steam is a soldering iron? What? I mean, people, the latest thing in all of the electronics videos is to use a drill, and you put a drill up against some other metal, and it'll get it to soldering temperature with friction. All right, so the pins have receded a little bit because I bent this to the side a little bit. And as I work this thing out, it's just going to get more and more crooked. You can do it evenly. Sometimes with big rows of things, when I've got lots and lots of pins that I need to desolder, well, yeah, you can cut the pins, but I want this to survive this process. I want the component and the board. So when I have large rows of things, you can rely on just that little bit of flexing that you get from it to help you take it step by step out of what it's soldered into. It's kind of what I'm doing here. And then I can come over to the other side. The board slipped. God damn it. This whole telling everybody exactly what I'm doing and having them run commentary on it is not great for me. I'm pushing up on it, as in towards the top row. There we go. A bit of that. I'll do a little bit of this. This. The desolder braid is really for cleaning this up after you've done the rest of the desoldering. There we go. And now I just need to come back here, and it's peeling away right now. There we go. And now our component is out, and it can be used again. Now, one thing you do have to be careful with when desoldering, especially on stuff like perforated prototyping board, is that when this part lifts away from the board, if the top pad, the pad on the other side of the board as I'm prying this downwards, that top pad can be pulled off. And I think that's exactly what happened right here. You can see right there that the pad has come with. Yep, there it is. The entire via, in fact, came out. The via is like a little rivet through the board, and it is only as strong as the FR4 material bonding with the copper. So in this case, it ripped out the one side. We'll still be able to solder it, and it looks like if it does go through the board, it'll still have the FR4, or sorry, the pad on this side, which is the good side to have it on because it'll act like a little rivet on the end. But that was because I was a little too hasty with removing it. But right now we need to remove the solder from all of these, and hopefully that pad stays on the board. In order to do that, we use the desoldering wick. It just does a much better job on this stuff. So I'm going to cut off the stuff that was already used. I run 666 degrees Fahrenheit. All right, so sometimes it is a little persistent that the solder in the via doesn't come out because of surface tension. It's holding that solder in. So this is where we would use the solder sucker to kind of blast everything out of the hole. I'm having some trouble with this tip. Might need to re-tin the tip. Oh, look at that. We kind of chewed away at some of that stuff there too. There are traces on the other side too that we're going to have to make sure are maintained. All right, so there's that. Press this thing in. Ooh, ow, that hurt. There you go. So that just goes right up against there. There we go. We removed this solder from around there. We'll do that to the other ones here too, since this is cheaper than solder braid. That one. And then right here. I think my iron actually takes it to its nearest neighbor temperature. I think it's 550 to be honest. I think it just does that because it's not that precise. Damn it. All right, so we lost one of the traces there, but that doesn't mean we won't be able to make an electrical connection. We can still work with that. So the temperature of the iron was such that it worked that metal piece off of the substrate, and it walked with us. So we need to compensate for that, which is fine. We'll be able to work with it. And this is just dressing up the pins so that they look nice. That was we kind of came through here a little too quickly and removed that, and it didn't want to go quietly into the night. It definitely fought us, and I could have been a little bit easier with the whole thing. So this just happens when you're using a very hot soldering iron and you're working too quickly. Whoops, I burnt all this stuff again. Jeez. Terrible. Okay, so anyway, now that that's all cleaned up, I can put the new potentiometer in. It's going to remain hot for a little bit, but now we'll have two 10Ks on this thing, which is more useful because the 10Ks are used quite often in projects. The 100K, every now and then you'd see one in a synthesizer thing. It seems like everybody kind of tries to keep that standard of 10 kilo ohms going. Why is that fighting me? There's a little solder in the via, I think, and it's kind of fighting me. There we go. Okay, cool. So that one's in there. Ooh, damn it. One of my legs bent. You only get a couple bends with these things. You got to be very careful about that. You only get like 1 or 2 bends per device. These leads will very quickly break. They're not made out of expensive material. So you can do little tricks like bending it against its buddies and just very carefully working it back into position. Yeah, the tube, the plunger has a little nub. See the little nub? And that'll push stuff out. And if that doesn't work, you can disassemble this and reassemble it. I put dielectric grease inside of it just because that's what I had on hand. But any type of grease that would help this thing do its job is appreciated. Oh, I see why, because there's... Wait a minute. Oh, that's not fully opened. Oh my god. Okay. Let's just open up that one via. Whoa. A sun reflector. All right, there we go. This one here is just fighting us a little bit. So I'm going to add a little solder to it and then remove the solder again. Hopefully that'll take everybody with it. Let the heat soak in. I could do this from the other side, but yeah, let's take a look at the other side. Because that immediately took up all that solder and it still kind of looks funky. Oh yeah, we could just use the sucker on that. I could go from one side to the other, but I often find that to be more trouble than it's worth. Yeah, these holes are not happy with me, but they don't need to be. There we go. So there's still a lot of residual solder, but there's a big enough hole that we can put the other pot in there and it'll work. Oh, yeah, that's much easier to push in. The reason it was resisting before is because that pin was like, I can't fit. And then it exploded. All right, so let's get this thing soldered in, and then we'll have our 10Ks, and then we'll be able to start building the fish noise maker. Make the fish noise. Do it. Make it. Make the fish noise. Is that crooked? No, that's in there. It's pretty good. Device is a little limiting in some ways. Yep, don't lose sight. We've got a goal. What I use to clean up is Goof Off, which is just orange flavored acetone. You can use a variety of chemicals to clean up. Acetone being pretty harsh on the plastics, so you don't want to let it linger. You don't have to let it linger. To answer that question, not in song form. I don't have to. I don't have to. I don't have to let it linger. Jeez, stop asking. Okay, so you basically apply and then wipe it off. I use Q-tips because they're made out of renewable materials, being paper products instead of plastic. I have had plastic Q-tips sent to me, and they were the most pathetic things in the light of the wonders of acetone. Yeah, isopropyl is the typical electronic cleaning fluid, and you should probably stock up on that anyway, but it's the typical one that you would use. I like my goof off. It's a little bit more harsh. It can damage stuff, but I use it properly. I don't just let stuff bathe in it. And actually now I do have an ultrasonic bath. At some point, see what I'm doing is I'm just adding solder to this point right here, which is dumb. Get off of that hole. This isn't the most accurate iron tip in the world. I didn't pull through far enough. I'm feeling very clumsy with the soldering today. I'm usually a more than professional at soldering. I'm better at soldering than all of you are. That's why I'm on a Twitch channel. I should do more show-offy kind of soldering stuff. The problem with that is, though, when you get to the smaller sizes of electronics, like the 0402s and stuff like that, it all looks like big electronics. You just don't see my hands to give it a sense of scale. So everything seems like it should go very smoothly, but it's extremely clumsy because of the scale of everything. It's so annoying that it doesn't look as show-offy as it is. I ran into that with Immutables Instruments stuff, because all of that stuff designed by Amelia is, or Amelia, I wish I knew how to say that name. All that stuff is using parts that are small, but they are the same dimensions scaled down of the larger parts. So I'm sitting there like, I'm not incompetent. I know what I'm doing. And it just like, it doesn't look like I know how to solder. I know how to solder. I'm good at it. So these are not connected at the moment. Some of them are just straight up not soldered because we're missing pads on some of the sides. I could just do a big solder bridge across it, or I could utilize some of the leftover little piece of wire. I gotta be careful how long I apply heat to these pins because they're not plugged in. Well, actually, let's just plug them into a perforated, a solderless breadboard. My brains are funny. Brains are funny. They'll bite your head if you're wearing meat on it. No, brains are weird. A long time ago, I wrote a Hackaday article and I mixed up perf board and breadboard. And once the Hackaday fans were done calling for my removal by force, I decided to learn the right way around, not because they said I should. And in doing so, I've made my brain not work right. In doing so, for some reason, I mixed them up. My brain says, wait, you were going to call it that? That's the wrong word. And then it flips itself to the wrong word. I really wish I had another angle of light here, but the only way to get light in is from this angle, and this is the angle that my hand blocks. Let's solder the broken carburetor back together so I didn't have to row a boat 5 miles without cars. What the heck? That sounds kind of cool. Hey, look at that. My shadow immediately just gets in the way. We got to figure out how to defeat my shadow in this setup. Maybe a ring light on the microscope? I think I have the makings of that project somewhere. Yeah, there's just nothing to solder to up here, I don't think. Oh, ores. Why did cars get into my brain? I can't see what I'm doing. That's what I used to do. I wear a headlamp while soldering, because if I'm looking at the thing up close, I might as well have a headlamp on. It works really well. But in this case, I have the fixed microscope because we are soldering together. So I've got to work with that. These are just 1/4-inch fuse holders. They do really well for holding on to the pace tips. I wanted to lock that down so that the switch tips, all I would have to do is vertically drop them in and then they would pull out of the thing. but those fuse holders don't grip enough. They don't have enough grip for me to do that. My pull-out game is very weak over there. This one just can't hold solder. There's just nothing on either side. It's literally just an FR4 hole. The light is really bothering me today. The amount of shadows that you guys saw just then. Sorry, a good artist gets mad at their own equipment. This really bothers me. Okay, well, whatever. I gotta live with it. The cameras are very carefully tuned to the amount of light that they get, and so when stuff gets in the way of that, it really bugs me because it's part of the visual representation of what's going on in my shop, which is a big part of streaming Twitch, which is a visual medium. So a lot of the presentation suffers from my direct shadow getting in the way of what I'm doing. So we're just going to get some uncoated wire wrapping wire. Actually, I've got enough leads sitting down on this desk that I think I can scrounge up enough metal. There's just loose metal all over this desk. And we can just solder those in. This piece of wire here. Perfect. I'm going to hold this with tweezers because this is a tiny little piece of wire, and this tiny little piece of wire is going to transmit heat just as well as it transmits, well, not just as well. It'll transmit heat as well as electricity, I should say. Let's put a little bend on the end of that because we don't have the pad up there. The light taking up most of my free space is very frustrating when I'm soldering on the setup. This is why having things up vertically is good, because when it's up vertically, my hand isn't getting in the way to shadow it. When it's down here on the desk, hands throwing shade. That is not really going to be good. Well, actually, I can go vertical. I can go like that, and then I'll have a lot of space for solder. What I want to do is tin this, and this is going to hurt my hand. I'm going to probably burn myself a little bit doing this. Just tinning is when you add solder to something, and if you're soldering two pieces of metal that have not been tinned, it takes a little longer because the solder has to coat the two surfaces properly. So if you tin them ahead of time, then it'll coat the wire. The two wires will bond to each other much faster because all you have to do is melt that solder, and so the solder will melt into place, and it'll become the interface between the two materials. So I do it like this, and I drop it on there. I don't know why I'm doing this by hand. I want my fingers to grip this a little bit, but it looks like tweezers are probably going to be better. This is getting a little fiddly. And this thing just keeps twisting in the wrong direction. It keeps trying to return to the default value of not what I intended. I do that vertical and I give it a side bend. Now you can't twist. That's right. It looks like it's a little far away. What does that look like in 3 dimensions? I got close. I think it's close enough. Now, the problem is when I add solder to this, this thing is going to transmit the heat so well that I think the whole piece is going to become molten, at which point it'll fall off. So I'm going to maybe try to keep this on here shorter than I would otherwise. Nope, it's already too long. Whew, I think we somehow got away with that. How do we get away with that? Yeah, we got away with that. This looks like it might be cold soldered a little. I'm going to add a little bit more solder to this pin. I don't know why I'm feeling so clumsy today. Maybe it's just the size of things, or I haven't warmed up properly to the soldering. It's not like it's a sport. I'm not like doing a couple laps before I start soldering something, but I mean, it is muscles that I'm using in order to do this. My giant rippling veiny muscles are acting upon the substrate, but I just don't feel that it's something I need to warm up in the morning. All right, so that was pressing down with the knife, and then I gave it a little bit of a bend, a little bit of a mechanical bend. This is a pin lead, so it's a little bit more robust towards repeat bending. However, if this were just the solid wire that I use to create stuff like this, I could just bend it a couple times, because this stuff is cheap. It's cheap metal, and this cheap metal only has a fixed number of very small number, fixed number of bends in it. And if you exceed those number of bends, then it just simply metal fatigues. And that sort of cheapness is the same reason why if you static electricity something enough, it will end up not functioning. Because every time, there's basically on the substrate, the silicon substrate of a chip, there is a gold bonded wire, a gold bonded pad, not like the powder, not like the talcum powder, but like gold bond, as in gold bonding, as in when you take a tiny little gold wire and you smash it really hard against a piece of silicon, it makes what is called a cold weld. The deformation of that gold, squishing it down, will make a cold weld bond. And that's what's used to connect silicon to a package, like a dip package, or whatever holds those big pins in place. When you static electricity something, a ton of voltage will go through that line, and it tends to erode the bond between the silicon substrate and the gold bonding wire. Over time, over a couple static shocks, with a statistical probability, it will eventually fail. Yo, what's up, FK? What's up, Frank? How's the kitchen? I'm feeling very clumsy today. This is very clumsy today. But yeah, that's why static electricity breaks the gold bond on the silicon substrate, and that's what makes your device no longer function. Hold on, I gotta hold my breath. Still doesn't look like it's close enough. All right, there. All of that just to replace a potentiometer. I learn new stuff every time I tune in. I got a lot of these little things, these little things that basically fill dead air. Otherwise, I'd be sitting here breathing into the microphone. You guys don't want that. I gotta remain entertaining and punchy. Hey, Frankie, what's up? Actually, wait, didn't we lost the patron saint, Dr. Giovanni. Dr. Giovanni dropped off at the soldering iron. I gotta put him back. This is the patron saint of brazing, Dr. Giovanni. Put him back up there. Perfect. That's where he lives. He's been there a long time, too. Socks and carpet are the AI overload's worst nightmare. I mean, when a bunch of toddlers running across a room can destroy your overlords. He's perfect in every time, Mad Max. Yeah, exactly. Every single time. He was perfect. He's wearing a fucking, like, face thong. I had a baby brother. Big load. No, big breadboard. Where did that go? See this light? God. This has been annoying me, because when we work directly down on the surface, that shadow gets in the way of my shot. My shots are very important. Okay. Input or output, I don't know, maybe output. Adjustment. We can finally get to the business of actually building the fish noise maker. What happens when solder paste expires? It becomes less effective. It's basically because it's on a liquid substrate. Solder paste is just a dust of solder. If you look at it under the microscope, you can actually see individual particles of solder inside of solder paste. Solder paste is what happens when you mix flux paste and dust solder. And so you get this paste left over. Flux and anything with a liquid in it eventually hardens, and so it becomes harder to use, and maybe this stuff doesn't quite work. You have a bunch that's a year expired. It might not spread as well when you try to, like, wipe it across a circuit or something like that. They say you should store it in the refrigerator, but putting it in the refrigerator is an OSHA act of chemical terrorism. because you're basically rendering that entire refrigerator unsafe for anything else. You know, food items should not be stored alongside solder. I have old solder paste that I don't know when it expired. We used it a little bit recently. Actually, this stuff, no, I had to buy new solder because it wouldn't dispense from the syringe. Hot air soldering is a lot of fun. Chad, a long time ago, bought me Louis Rossmann's hot air soldering station. I'm pretty sure they bought this new. They didn't break into Louis Rossmann's like setup and steal it. Maybe they did. But then they also got me the extraordinarily expensive bent solder tip, the 45-degree angle one. What if you put it in a glass jar? It's only as chemically sterile as you will allow it to be, and I'm not OSHA, so you can go ahead and Google that if you want. This stuff has expired... Never? March 20th, 2020. What are you going to do? You have the same one. It's a good one. It works really, really well. I try to avoid it because it's not a common tool that all of the people watching the show have. But that being said, desoldering stations and hot air stations are getting extremely cheap. So no longer can I claim that people don't have these tools. They do. All right, now we're making the fish noise. Fish will be attracted by strange underwater noise. How would you categorize the fish noise? So 3 volts we've got on a power supply. Capacitors, I got the kit sitting in front of me. Although these are polar caps. 10K, 33K, 15K. Let's start building. I think we're ready to start building. We have to make the fish noise before the sunspots kill us all. Or no, what was it again? It was the solar flare. The solar flare's coming, chat. It's coming tonight. We need to make the fish noise before it all goes. Okay? We have a limited amount of time before the solar flare gets us. We have to make the fish noise. All right, so starting out. Now, do ceramics matter? SG4 2005, my backups are ready. I don't really think it's going to do all that much. But we should be able to see the northern lights if you're not in fucking Philadelphia, like I am. The clouds. We've got rain all day today. I don't know if the clouds are going to clear by tonight. I want to see northern lights. I've never seen northern lights. Son of a bitch. I'm going to have to go break into Rob Oz's apartment and fucking sleep on his couch for a little while so I can see northern lights. And he'll be like, those are just normal northern lights. Why do you give a fuck about that? Like, do you know how special that is in your paper town with nothing but a burger shop? Fish caller. Based on a hopeful theory that fish will be attracted by strange underwater noise. Okay. Consists of 2 transistor tone generator and a small speaker mounted in a waterproof case for lowering into water. Change settings of pots. Gives a variety of tones. A fishy project? ? Popular Electronics, March 1971. I hate the little quip at the end. It's like the how it's made guy making his little pun. They're like, hee, I did the thing. Did you guys know I'm a bit of a silly guy? It's like, oh, shut the fuck up. All right, so we got 2 10Ks and we have ceramic or polar caps. I'm not sure. Maybe we should try to build it with the polarized capacitors and see what happens. If the fish do indeed come to my house with knives. Let's do this thing over here then. This is going to be much more annoying to breadboard because these guys are kind of annoying. Actually, I don't think I'm going to be able to do values that are that small. 0.02 UF. Those are puff values. Yeah, it's like 4.7 is as low as these go. So I guess we're going to use ceramics. We'll use these nice ones. I'm going to be on a flight. Hopefully it's a good view. That does sound awesome. You might get a great view. Nighttime solar flare. Solar flare! Okay, so start the circuit. We're going to assume that power and ground are going to be 3 volts. I'll try to keep it on this side. Try to keep the 3 volts on this side so that everything is... We only have to put power into one of these rails. Otherwise, I've got to jump across the whole perf board to do it. We need 2 transistors Okay, so here's the last bit of book work that we need to do before we get started. So the last bit of prep work is the 2N. What is it? 39. What the fuck? 2N 3565. 2N 3565. 2N. I'm going to look up a data sheet because I need to know what that pinout is because I'm dumb and I haven't memorized everything. 2N 39. Is it 65? So you guys know I don't really go like play into the VIP thing. I used to have a rule that if somebody gifted 100 subs, they'd get VIP. The standing rule is that if somebody can show up at my house and I will not call the cops, like if they show up at my house and I look outside and I'm pleasantly surprised that they're there, they get a VIP. So there's enough people that are kind of local that I've done that with, and otherwise I don't like having super people in the chat, you know? Everybody's at the same level unless I know your name or you're a partner on the channel. There's nothing to this data sheet. It's one page. Partner to the platform. Bipolar PNP with a hermetically sealed TO18 metal package. VCEO. What? Time to show up at Bother's house and see my outcome? You'll see your maker. Okay, VCEO. 45 volt. I mean, we're in a 3 volt system. We got no curves for this thing. So I'm going to say 3904 is probably going to be the one that we use. We're just going to use a generic PNP. So 2N39, let's just look up the 04. It's either a 4 or 6. I forget. Is it 2N3904? Is that PNP or 3 and 4? Points down. Yeah, that's the one. Okay, so we'll use that one. Pins 1, 2, 3. See how they did this in 3D to not be confusing? It's so confusing. I'm so confused all the time. So pin 1 is the emitter. Pin 3 is the collector. And the one in the middle is the base. Cool. Nice and easy. So 3904. Oh shit, we only have these. BC 548. No, wait a minute. I've got another kit. I've got another kit that has 3904s. What happens if you use 2? That's fine. I'm sure it works. The 2N2222222 is a very common jelly bean part. What we mean by that is that for some reason the people coming up with this stupid terminology assume everybody has jelly beans, which, you know, I'm a diabetic. They're being racist. But anyway, jelly bean parts are the parts that you assume that everybody should just have. And so the 2N22222 is obsolete. It is no longer needed. Its services are not required. But it is one of these jelly bean components that everybody's making stuff with. You can find a billion different equivalents, and you can even buy 2N222222222s pretty much everywhere. I guess I don't have... There are probably a couple in here. I don't want to find them. These are all just spillover through-hole parts that I've used to breadboard things in the past. Maybe we can look in here and see if I can find a 3904. I guess I don't have the kit that I thought I had. This is all I got in terms of through-hole transistors. Should have done a shop day on Friday. I should have done like building something, or in the past, I would just have to sit here and be a boob like you guys are and commentary on things that I'm taking apart. But I ran out of stuff to take apart. I took apart all my stuff and I couldn't afford to buy new stuff. I can't even see the text. Let me bring the light in here. Taking apart controllers and stuff was a lot of fun. 2N7000. That's a weird one. So a long time ago, instead of sending a 3D printer like they were going to, because apparently Twisted Sister was going to give me a 3D printer, and that never happened, so I ended up just buying one. But chat thought that the 3D printer fund that they had been saving up was going to be usurped by the printer that was sent in. So they used that money to buy a bunch of stuff that was kind of frustrating for them to watch me struggle with. And so they ended up getting me a bunch of through-hole components through-hole jelly bean components, a hot air solder station, that was the big purchase, and a couple of other things. So these are the holdovers from that. All right, I think all the ones in this bin are going to be the same value. A bunch of 555s too. I need tweezers to get into this bin. Might be voltage regulators. 3906. We're looking for 3904 though. These are the PNPs to the NPNs. That sounds cool. This is a long time ago, yeah. 3906. Probably the same thing, right? Yeah. I have to go to a different bin to get the what I'm looking for. All right. I think there's going to be one in here somewhere. Just a matter of fishing through a lot of this stuff. 3906. Damn it. Show me your 3904s. Why are you not twisted the way? I wanted you to go the other way. I need to see the front of the thing. You bastard. Oh, because one of the leads is bent backwards. That's a 6. Another 6. Ugh. There's got to be something in here. None of this stuff's relevant. This is just what I do with the old breadboard circuits. I just throw them all in here. Oh Lord, I have no idea what this one is. This one might actually be what we're looking for. Let's just put on a little extra board. If it says what JA on it, I can't see what the text is there. It's not a JFET. It's not what it says. It's not a JFET. How did I know you'd fucking chime in? As if I was unable to read this. Now, anyway, moving on. Looking for what I'm actually looking for. So these are all 3904s. Or 6s rather. No, those are the 7000s. All right, so we're using whatever the British equivalent is, which is the BC 50 whatever's. 548. We just double check that. Let's just double check that. BC 548 data 6789, etc. NPN epitopal silicon transistor CBE. Okay, and switching amplifier, high voltage up to 65 volts. Where's our other data sheet? Well, we lost that other the New Jersey data sheet. That I think it was like 45. This one goes up to 65. Hopefully the curves are similar. So we can use this one. We'll just use the 546 or 7 or 8. It doesn't really matter. Just make sure it's the right one. 6, 7, 8, 9, and 550. So we'll use a 548 because it's just in the upper right corner of this thing. Now we just face these against each other in a battle of voltages with 3 volts on the line. In the fashion that the book tells us. The 1K right there. Okay, so where are we starting this circuit? I almost need to just like move the camera over to that. Move the microscope over to that. That's like way over there though. Where's the micro on this thing? BG, blah, 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 blah. Stand cam? Nope. Scope. Scope? Hello? Okay, so I guess that doesn't work. Weird. Hold on, go to the properties. Maybe it just doesn't recognize it. URL? What the hell? Oh, that's my, that's the oscilloscope. Okay, hold on, close that. Sorry. Posit 1? No. Known cam? No. MS Paint? No. Not that one. That's from another stream. I don't think I have a microscope overlay. Weird. I thought I had one in this view. That would have been nice. That would have helped us put the schematic right up here. I guess I could just do it. Okay, let's just add it. Let's add it. I'm going to add a scene, and it's going to be a capture device. The webcam. Like, I haven't used OBS like in any serious manner in a long time, so it's like it's almost like I don't know what I'm doing. Video capture device. There we go. Add existing, and then it's going to be the microscope. And then I lower the size of that until it's just up there and in the corner. That should do. And we'll just keep it looking a little janky. So now I can go down here, look at what we're doing, and then at the same time, I can prop this big old book up over here, move the scope so that it's viewing it. Whoa. Which one? What are we looking at? Up here. There's our circuit. The fish noise maker. Why is that? Oh, because this thing sucks. All right, hold on. It's just the weight of the camera is pulling it down a little bit. Come on, just hold up right there. Ugh, stupid thing. It's actually like a gauge thing for like measuring, and so it's got this little screw thing that allows you to move the measuring tool slightly up and down, and that spring is what it's fighting against. So fish collar, there we go. So there's our circuit. Okay, so we're going to assume that these rails are +3 and -3, and then we can start with a transistor, and they're both connected to ground, so the emitter of both. So the thing that's on this side right here, this is the emitter that's connected to ground. So these are going to make some funky jumps. So emitter's there, collector up to the speaker, base is there. This is a weird circuit. This is one of those ones where it's like push-pull on the transistors. But so let's take our first one and just go over like this, and we'll go to these 2 rows of holes like there, and then we'll figure out the rest of it from there. I mean, it's going to be a little bit sloppy. So I'm going to move all the way down here and do the same thing with this one. Try to spread out a little bit. We don't know what the circuit is going to look like yet, but we'll see what we can do with arranging it. Okay, both transistors are in. We have, oh, I see. One of the 10Ks is just connected to ground. So I will do from here up to there with, oh, there's a jumper kit. Oh, is this thing resting on that? Is that gonna, okay, that didn't change our angle. So let's just jump over to that thing. And then I guess it's 2 pins that are next to each other. So there's a little one position jumper on that. These are these ones without any jacket on it. 1 position jump. Oh, that's not. Gotta push it together a little bit. 1 position jumper. So the thing that we built last stream, the oscilloscope for a modular synthesizer setup, needs a code thing. I need to do a lot of coding to get that thing off the ground. Hajiwo does a great circuit. He really does. He builds great stuff. But I can't sleep at night unless that code is looking good. So I need to rearrange a lot of things. I need to kind of make it a lot bit more organized so that I can sleep at night. Basically what I do is I take a standard like skeleton form of what my code usually looks like, which is highly organized. It's like, here are variables, here are our pin settings, here's this, that, the other thing, and I have a place for everything. And so I'll take the blocks from Hajiwo's stuff and move it over to mine. And then I'm switching over to the bounce library to debounce the button, things like that. Like things that I know how to do, I'm sort of doing in my own way. And there's just a whole lot of little things like that that I gotta manage. All right, so we got two caps that then go from there. They go to the collector and the emitter, and then those two are connected by what value is that? 1 UF? Is that 1? That's a 1, right? I think that's a 1. I can barely see it. So 1 oof. I think I might have a 1 UF in the actual polar capacitors. Let me get that bin out again. I think it might be under this. No, it's not. Make sure this is positioned exactly right. Fish collar. Did you have a fish collar last night? Where did my caps go? They're not under here. No, they're back in the bin. That's where they went. Back in the bin. There. I could probably find a 1 UF in here. This whole system is 3 volts, so I don't really have to worry about voltages. That's 100. It's probably going to be a anemic little thing. That's 47. Well, this won't even fit into the breadboard. That's 100 again. Where's like the thinnest one in here? Because I think that'll probably be 1 UF. 1 oof. Dot MP3. 100. No. 3.3. All right, screw this. These are all bigger values. I tried to get a big like through hole thing, but it just never works out. NF. Really? We don't get out of NUF in here? Okay. Where am I going to get 1 UF from? Maybe I'm going to have to build something. Unless I find it on another PCB. I don't have a lot of stuff that has caps sticking out of it all over the place, though. What about that little collection of through-hole parts? Are there any 1 UFs in ya? I don't think so. 1 UF is a value that I've seen a lot in musical stuff. And I don't have a ton of them. Probably should have bought them last time I discovered this. Like, what are these little guys? 0.1 UF. Do we have any 0.1s in the circuit? 0.2 UF in 2 places. That's this one is 0.1, but this one is 1. And so that's the one we're looking for. Not finding it. $4.7. There is 1 UF. What are you? Here's a capacitor on a little through-hole adapter. Maybe I need to measure this and see if it's 1 UF. So let's get the multimeter out here. Who knew that this would be the stumbling point of the circuit, is that I don't have a 1 UF. I probably have it in surface mount, which is why I'm testing this part right now. So this thing barely does a great job with capacitors, but it does do them. So if it's anywhere near 1 oof, I think we can count it. Really? One nanofarad. What is 1 nanofarad in farad? I always mess that up. That'd be 0.001? 0001? 82 is 0.082, so 0.001. Do we have that anywhere in this circuit? No. 0.005 is actually used. 0.1. Okay. So we'll have to make one. So let's get a piece of header and actually make an adapter that'll have the right value. Well, let's check to see if I have the surface mount one first. I do typically have a lot of surface mount though. 1 UF, 10 UF. None of these are 1. Uh-oh. These are 0.1. 10 UF, 2.2, 0.7, 0.33, and we go down in value from there. So our only hope is going to be the capacitor book and or stealing one from somewhere where we know the capacitor values. Curse all these circuits that use these parts that I don't have. I tried to bolster up my collection of components to handle these audio circuits, but one-off is... It is. Yeah, I looked around on a bunch of circuit boards that I have, and I don't think any of them have one-off. I think I've done this exact exercise before. Puff, 470 puff, 10 NF, one-off. Okay, so we got the one-offs. They are ceramic, but they are in this kit. So we'll put one onto a surface mount thing. And for that, I just use female header. And then use the top of the female header as pads. So I think I had a piece of that header somewhere around here. I don't remember what I did with it. Oh, here it is. Okay. This piece right here. And we'll just make that into our SMD header. Clip it. Yeah, it's such a simple circuit, and then it's like, oh, but you need to do all this stuff to get it running. You need to find exactly the parts, you need to find this and that. It takes like a week to put this stuff together unless you've got a fully featured... Well, I do have a fully featured shop. Even with a fully featured shop, it takes a goddamn year to put all this stuff together. Why would I make a capacitor? Aluminum foil or pop cans and paper. I'm not building my own... This is weird. Just... I know you can manage somewhat, but it's like... Hooking that stuff up to like this is not... Especially when these are like cents on the dollar. The whole book cost me like 14 bucks. Luckily, we've got a lot of them in the book, so... One off. Come on, there we go. I hope I don't need to do that with every single capacitor value in here. Bringing friends, uh-oh. Cosmo Questix is talking about the solar flare. Doing this without the microscope is a lot more clunky. But basically what I'm doing is I'm soldering the capacitor across these two female pin headers. And then just slapping a bunch of solder on it so that everybody makes a connection. Yeah, I know, that's exactly what in my mind's eye as well. Just a bunch of toilet paper tubes and like tape, masking tape and cardboard. I'm not Mr. Wizard. I'm not building this stuff in a high school science or a grade school science setup. These are much more stable to getting bumped. No, the microscope is actually on the fish circuit. That's what camera's bringing us this right here. So, so that's this one. And it's connected to the collector, which is the pin 1 of this thing. So I'm actually going to spread these out a little bit. I'm going to move the pins out. Just do that by doing that. There we go. Nice and spread there so that I can actually access these pins from multiple different angles. So the collectors are the ones that are going up over here. So this is going to go on that. Just like that. Oh, wrong way. So that's that capacitor there. That capacitor also connects to the base of the other transistor. Yeah, well, what was that noise? I'm the only person here. Okay, nothing. Oh, there was already a raid. Oh, with Party 14. Hey, how's everybody doing? I'm home alone today. No dog, no roommates, nothing. All I have is my cameras that notify me of motion at the garage. I think I have ghosts here. Anyway, the point is, before the solar flare kills us all, we need to make the fish noise. We need to make the fish noise. We have to. We have to make the fish noise, okay? We just have to. So that's what we're working on right now. Sorry, I didn't know you guys raided. I didn't get a notification anywhere. I need to fix that. I need to make the bother flasher. Doesn't matter that it's not polarized. Sometimes I can't find anything that's polarized, though. So it's what it's. It's not my fault, but we do have to make the fish noise, and we're not doing very well. It's already 3:30, and I haven't made the fish noise. What's my problem? We have to make the fish noise. Or it'll be the death of us all. I don't know. It's the solar flare is going to hit. It all started with a buzzing rocket valve. Don't you speak ill of the fish noise? Don't you speak ill of the fish noise with no knowledge yourself? Unknowledgeable chat member. It's my fish noise and I want it now. All right, let's get to wiring this puppy. Oh, that reminds me that I don't have my puppy here. I miss her. I miss my puppy. Okay, so we've got our tiny little capacitor here that's hooked up to the collector, and the other side of it goes to the base, which is just a couple holes off of where I am. This line going across my breadboard is really going to annoy me at some point. But anyway, I guess I could just get a slightly longer lead. Put that one in there. The thing about breadboarding, at least in my mind, is that everything should be very precisely organized and neat, and you don't want stuff jumping over other stuff. Now, there's going to be a way that I can arrange this where things will be perfect, but since this is our first blush at the circuit, I should probably not stress perfection all that hard. You know, a circuit connection is a circuit connection. It doesn't have to be totally great, but the more neat that you make it, the more organized and clean that you make these connections, the easier it's going to be to troubleshoot your circuit when it doesn't work. Something explodes, you can say, well, that exploded because of this. Instead of going, well, if I press on this, it works a little bit more. Just because of janky circuit construction. All right, so we have our potentiometer coming in here. Probably bring you guys a little closer to what we're doing. I'm giving you guys sort of the broad overview. I should actually be in here where we're actually working. So we're trying to construct this circuit, and we've got our collector here and our collector here. The collector here goes to a 1 oof that then comes over to the base. This base also needs to go with a 0.01 oof. So the 0.01 I have, 0.01 over here. 0.01 is the common oof value that you would use for a decoupling capacitor. In this case, it just represents a very small time constant. Capacitors are math, and capacitors do stuff with time and charge. And so there is an equation, just like everything else in these stupid circuits, there's an equation that dictates how the capacitor operates and what values do what at voltages. And I guess what we're doing here is we're just flipping back and forth between these two transistors. And the two transistors look like they have different voltage potentials associated with them. Who knows? We'll find out when we make the fish noise. So this would be a point... Wait, I got a 0.1, but I needed a 0.2, I think. Yeah, that's a 0.2. There will be a 0.1 later on in the circuit, so we'll just put that right there. Well, I don't have 0.2. I have 0.22. Good enough. Good enough. The solar flare is going to kill us all. We need to make the fish noise. That's just what needs to happen, okay? I said all right and okay is sort of a compound word just then. So coming off of our 10K potentiometer to ground, we still need to connect those two to ground, but we have this one and then this one, and I need them to go to different holes. We haven't done our due diligence here. Hold on a second. I need to get this over here connected to ground. So I can either go up here, which means that I need a jumper across the whole thing. Yeah, I'll do that. Go all the way over there, and then I'll do this. Not long enough. I'm having trouble with this new kit that I bought. This new kit that I bought doesn't have, it's got even more of a limited number of lead lengths. The fish are going to know. They're going to feel that. Well, the fish can deal. Not often that we make the fish noise. They can handle a subpar noise. Those little shits. I go through my day, make all this hullabaloo about making the fish noise. They're not even polite enough. All right, so fish noise, ground to the capacitor, that's this here, to the 0.2 UFs. So I brought this over to here, and now I need 2.2, and I have 2.22s. And the first 0.22 I'll put over here, and that one goes to the one on the right, and it goes to the base of the one on the right, along with, so if I actually could get it over to this capacitor here, that goes to there. Yeah, if I could get this one to go right over here. It's off by 1 pin, but that's fine. I can just drop a jumper right there. These need to be pinched before I put them in. Okay, so the 0.1 UF, that would be this, from the collector goes to the base and a 0.2. So it goes 0.1 to the 0.2 and then the base. Good, we got that part of the circuit done. Now we have another 0.2 that goes up to this other circuit cluster. So I will put that down and bring it out to another area. And that's going to involve the other potentiometer. So actually, I'm going to want to really like pull it away. Let's do that, and then we'll go up and over, I guess, to the pot. Because does that 0.2, it goes up, yeah, and it goes to, oh no, it goes to another capacitor before it hits the potentiometer. So that hits our 0.1. So we can actually pull that, I guess, over here. I should probably reverse this. Yeah, let's do that. If we're going to build the circuit over in this area, I'm going to grab this, and I'm going to put this one like that. No, it doesn't want to go in there. You bastard. It'll only go in those locations. All right. Let's see. The thing we built doesn't quite fit in the way I want it to. Actually, this is fine because that's going to the 1 pin of the pot, and I can just move this over to the other side. Bring that over to here. And there's our circuit. Sans ground. Sans Undertale? Sans ground. And I can just pull ground over there like this. 2-2, like the 2N, 2-2. It's off by 1. God damn it. Wait, no. No, it's fine. It's fine. This is off by 1. Bring this over here. You, hold on. Just wait right there. Stuff is so fiddly. For my senior design, we had a teammate who needed to be writing our final report, and instead he had to build this wire wrap circuit for an electronics class. So I ended up having to sit there in my free time and hastily wire wrap an entire course's worth of work onto a perforated board. It worked the first try, but it was a little circuit that used an A to D and a counter in order to store audio information in RAM. It was kind of cool. Okay, so now we've got, oh, this is between here and this. So actually having that on the other, having it the way it was might have been preferable. God damn these little weirdo circuits. What can I do about that? I mean, I don't want to flip the script on the whole thing. I guess I could just build the other part over here, and then I'll have a line that comes all the way over to this transistor. That's just how it'll be. It was actually okay in the other orientation. Oh well. LOL. LMAO. L. So that one's going to be the one over there. That's going to get a 18K. Is that 18? I'm going to lean in 15K. 15K to 3 volts. That'll be a nice and easy one to do. If I recall correctly, we do have 15K, right? Let's check. 15 kilo ohms. 56, 33, 15K. And it also says, fuck you on the 15K. Well, fuck you. You're going to insult me like that. Oh, it just says fuck. Oh, sorry. Sorry I laid you out like that. I mean to drop no bombs. 15K to positive 3 volts. So that's easy enough, and that's coming from the collector. So this side of the one-off could go over to there, but that would mean I need to fish another wire through. So I'll just go here down to there. I'll use my little measurement tool. It's a little plastic thing that's way too expensive for what it is. You probably, there's a bunch of things like it that you can 3D print, but this thing just enables you to probe the length of the thing that you want to wire, and then you just kind of do it. Yeah, you just kind of do it. I'm going to move this up one. Like that. Lock it in. I don't think it's going to fit, actually. That ain't going to fit. So I'll just do this to the maximum smallness. I like laying the resistors down flat, because then if something bumps into this, like if you're doing a multi-day circuit, you don't have to worry about stuff bumping into it and ruining your whole effort. But I could really go for resistors that have larger leads on them. The older ones that have big old stinky leads on them, because then they clip into these much better. We run into problems sometimes with this stuff where things aren't quite connected the way they could be, and you have to like wiggle the components a little bit to get them to work. That bugs me to no end. Things should not work like that, but they do sometimes. All right, so there's that collector. Actually, I can move that in a little bit. There we go. Now everybody's got easier leads. There we go. That's the stuff right there. Cool. Okay, so base of this one, we did the resistor to positive. We have the 0.1 UF coming off of it over here. And now we have another resistor to... Okay, so that's going to be that. Where's our output? Are we going to put that on this thing, or are we going to put that on the speaker? I think we're going to put that on the speaker. Yeah, WT, willing to buy resistors with thicker leads. I need them. I'm going to put jumpers on it, but I need to like mark where the speaker output is. What do I have? It's like 2 pin, maybe like a 2 pins of a header. Maybe. Do we have a stray 2-pin header sitting around? Usually at the bottom of this pin, there's a couple of things. Sometimes those couple things being a 2-pin header. I thought I saw one. Oh, it was 3 pins. 2-pin header. Glad it's not raining tomorrow. I'm not going to be streaming because I have a LAN party tomorrow, and my windshield wipers don't work. Well, they do work. The driver's side windshield wiper works. The passenger side windshield wiper does not. This is going to be the speaker. So where are we going to put this speaker? It goes between a cursed circuit junction and another completely cursed circuit junction. So it goes between positive and just absolute crazy town over here. That would be this pin here. So if we put that here, this can be our hookup for the speaker, and then the other end goes to the battery. What the heck? So we're pulling down from 3 volts through the speaker. Yeah, we got a little LAN party. It's my car buddies. We might try Fallout 76. That's been floated as a possibility, but I don't think that's really a LAN party game, because most of us aren't going to have that much time to play. And that game seems to be entirely engineered to suck time. Okay, so positive power to the speaker would be this. Oh, a little bigger than that one. I have to make the fish noise. I'm not allowed to stop streaming until I make the fish noise. So we need to get through this circuit. It's getting a little ponderously slow. Listen, we're going to listen to it in our own medium, okay? And that's oxygen. That's the air that we breathe. And the fish are just going to have to deal. I will not be sinking this into my glass of water. Why was that acting so weird? I think there was like a hair on it or something that was pulling it weird. Maybe you should go in the water, huh? Jeez. Why are electronic streamers so prickly? I don't know. It's because it's fun to yell at somebody when you're building a circuit, because all of your confidence is being sucked into this thing. I can't even build the simplest little thing, and yet this chatter is talking to me. I need to be mean. Okay, so let's see. Positive voltage goes there. Positive voltage goes here. It's just positive voltage, though. This is all the same trace. So we don't need to take, like, plus from the speaker and move it over to there. We don't... The following of these connections is simply mechanical. It's just that this, and this are connected to positive power. If we wanted to draw an arrow here, we would draw an arrow there to decouple them, and then you could start rearranging the circuit so that it looked better than this, which is what this circuit author should have done, and they didn't do. These should have been slightly rearranged to be a little bit more analyzable so that we could, at a glance, figure out what this thing is doing. But anyway, so we just got to deal with this the way it is. So those are all connected to positive. We have another 33 connected to positive, and that's going to be a little cluster of circuits that then go to the collector here and the base here. And between them, a 0.005 oof. What the oof dot mpeg? 0.00, not likely. But I probably have it elsewhere. Wait a minute, over here. 0.0027, 3947, 56. I hate it how it makes that jump. I don't know what the physics is behind this stuff. 47 is close enough to 5. We're going to use 47. Shit is an audio company, and they make great equipment. They're like the affordable, fancy audio company. So don't sell yourself short. 0.005 goes from base to collector and cluster. Well, collector's all the way over here. If I drop this here, I can jump from here to here. Where's it go on base? Base is going to be out here. Yeah, let's try that. So I'll go over here like this. And then I'm not connecting to anything. This is a different rail there. And then I can do... This is going to all be on top of itself. Here actually. Oh, it needs to go a little further than that. Okay, let's see. Red. If it ain't red, then it's going to be tough to run. Red ain't it. That ain't the right length. Okay, so I guess what I can do is pull the base goes... Wait, which one is that? Collector. So collector 0.05, and then it'll go into this. So I put this down here. Then I have to go from here to here. That's a much longer distance, but these leads skip distances, so it actually benefits me more. I can go from here, across, way too far. Damn it. There's no elegant solutions here. Make my own. All right, let's see here. Anaconda aquaponics. Party of one. Welcome, all of you, one person. It's the solar flare. The solar flare has claimed another stream. Oh my god. It's coming for us all, chat, and we have to make the fish noise. It's our only hope. Well, thanks for trying. I appreciate you. Hey, thank you for the raid. Thank you. What are you guys working on over there? Because it's definitely not, well, my aquaponics. What is ponics? Because hydroponics would be growing plants in water. Is aquaponics just the same thing? I've solved my fish problem today. Listen, we have to make the fish noise. The solar flare is coming for us all. We have to make the fish noise. Grow plants with fish. Oh, I love doing that stuff. That's right, aquaponics. I should know that word. Yeah, I used to love doing that. Cleaning stuff was always very annoying, but it was a lot of fun to plant like a freshwater tank and do all of the cool landscaping and stuff with water plants. The best I got right now is a garden full of peppers, sitting in the other part of the basement on a lamp that's turning on and off with sunlight and sunset. The only problem is nothing's growing. Nothing is growing. I don't know what the hell the deal is. I made the whole Node Red thing, and I made sure that the thing turns on and off on the appropriate timing. And it's at 70 degrees at almost all times, and the peppers just aren't growing. I don't know what the deal is. Anyway, we have to make the fish noise. This is a tome of circuits. This is a giant circuit book from 1974, and it's got all kinds of cool stuff in it. But the solar flare is coming for us. It's coming for us tonight. We've run out of time. We have to make the fish noise. I said I would build the fish noise 2 Fridays ago, but this is the fish noise. We have to make the fish noise. Fish poop is good fertilizer for peppers. Do you just type whatever comes into your head? Or is there a filter between, like, the brain and the hands? Talking catfish make a noise? I've never heard of the fish noise. Chat, we have to make the fish noise. We're running out of time. Okay, so let's see here. I'm going to get my other circuit, my other breadboarding kit, and see if we can't find a jumper length to actually do the thing that I want to do. Really, they actually make little noises. Yeah, most of my fish stuff was cichlids. I had a lot of fun with those, though. But it eventually, you know, having a 100-gallon tank, like, attached to me was not something that I could sustain. So I ended up giving them all to my fish friend. I think he found them homes, or he ate them. I don't know. Whatever fish do. We're jumping it over to here. That junction is... What is that junction? It's 0.005. Wait, the 0.005 never touches our... It touches a 0.2, but it doesn't actually touch the base. Oh no, the base of this one with the 0.005. And then this one goes to this junction, which is... No, that's not the 0.05 goes here. Oh my god. This I'm getting turned around. Okay, I gotta concentrate on what I'm doing for a second here, chat. Can the circuit pick up EMP from the solar flare? I don't know. I don't know. Would the government tell me if it could? Base of this, 0.005, and then we go into this godforsaken thing. So that would be these two over here. The problem is I'm streaming, I'm reading comments, I'm thinking about the circuit, I'm trying to move my body in a way that's equitable and actually allows me to work on these circuits and not get too much of my hands and stuff in the way. I'm making sure that I'm in focus, I'm making sure that my audio is good. I have a Has-Been Hotel song stuck in my head for the last 24 hours, and I've got to think about dinner in a minute. So I have a lot of stuff going on inside of my brain cage. Most of it is involuntary, and I don't need the distraction right now. Where were we? Where were we? 33K, 10K. So I've got from power, which is not on this side of the board. We're keeping power over here. So from the other side of the potentiometer, I want to go to a 33K, and I want to go to positive down here. So let's get a 33K. Yeah, but what is the fish noise? It's the noise we have to make because the solar flare is coming. 22, 33. Good. This doesn't actually have the value of the resistor. Yeah, there's a solar flare that's going to be, there might be, if you're on the, well, actually, depending on where you are, you need to look up on a map, but there's apparently, depending on where you are on the map, you might be able to see an aurora, which is not something we can typically see where I am. In North America. I don't know if you're in North America or not. That's the other one. You can't just assume somebody is in North America, bother. By hell I can, I'm an American. Okay, let's cut that. Nice and long. So that's going to go here. And then we'll flip it. Knock this thing up there. Ugh, bent all weird. Okay, hold on. We can deal with this. Man, that would make a good stream, is doing hydroponics. Or whatever that is. Not hydroponics. Aquaponics, I guess is what it's called. Be very satisfying, and then you just let the cameras roll on it. You watch all the little fishies do stuff. Look at them go. This one goes to the singular side, so we'll go right there. Now, the problem is I have to mark off where this thing is going to bend relatively accurately. Let's do that, and then I need to bend it down instead of out. That one's a bad bend because I bent it against my finger. Good enough for this though, and so I got to cut that a little shorter so it fits. What the feet? There we go. Okay, so this is like, we don't typically only do breadboarding circuits on this stream. I do all kinds of different hobby projects, mainly electronics stuff. I try to keep it kind of electronics. I try to do a bunch of gaming, but that, you know, sometimes you run out of gaming stuff to do. But generally, we do project-y kind of stuff here, building things with our mitts. So I am an extreme expert in soldering. I'm very good at reverse engineering, and I can do a little bit of programming. So those are really where my skills lie, and we try to kind of keep within that kind of stuff. Lately, we've been doing Burn the Subs and the synthesizer project. So that is a, I wouldn't say functional, but that's a modular synthesizer there that I've been working on for quite a while. I've also got a steering wheel project that I've done. Obviously, it needs a little stuff. Nothing can really end up in a finished state, to be honest, unless you live in Finland. Haha. Okay, so that's the 33K to the potentiometer. The potentiometer gets a 0.1 oof, so 0.1 oof goes only between those two junctions. So we're going to jump that over to here, to this little open area right there. So I need a 0.1 oof. Oof.jpg. Oh wait, this is the 0.1. Right, this is the 0.1 that we grabbed earlier. Those following along at home, we grabbed a 0.1 UF earlier and heated it to temperature. Okay, so 0.1 UF goes there. And then from there, it goes to this accursed union of 1,000 different things. 3 things that are unified right there. And one of them is the speaker lead. So if I can go from here to here, or if I could jump over to here, these are not quite going to make it. No, I guess that does okay. So now that I've made that jump, I can just jump from there to the one speaker lead. Get it? Because it's the worst humor. Okay, it's just so stupid. These are all the directions that my brain goes in at once. It's quite alarming, actually. All right, that right there, that's our first connection to the speaker. Aside from the thing pulling it down. I have a feeling there's a better way to represent the circuit, to draw it in a way that would make it easier for me to breadboard it. There we go. Okay, so now we have the 0.1 oof connected to the potentiometer, and then it also goes to the speaker. The speaker has the collector of the transistor on it. We need to get 0.2 to the other 0.2. That's this here that hasn't been connected yet. So that needs to go over to here. That's actually not a hard thing to do. So I'll bungle it. Move this down. Things are getting a little dense here in Circuit Town. Oh, you're kidding me. Come on, just jump the distance. Just do it. All right, there we go. That actually works perfectly. And it looks nice to boot. Okay, so there's the 0.2. That leads to the 100K over here. And then the 100K goes to ground. That's actually connected all the way down here. Tilapia farming goes very well with aquaponics. You can grow your whole meal in one garden. Tilapia and seaweed. I guess there are worse meals. Tilapia is not a very flavorful fish. Okay, so then again, if you grow your own barbecue sauce, you could actually make a pretty good meal. Let's see, 0.2 oof. That's that one. That goes there. That goes up here. We are missing the 0.05. Did we get that? Oh, that's all the way out here. And the other side of the 0.05 goes to, oh my God. That's the wrong collector. It doesn't, it goes to the base. So this is here, 0.05. And this is the other side of the 0.05, which is the junction where we were just working. That's the speaker terminal all the way over here. So I don't have any more room to put anything down here. I have a line that I could do here and take it all the way over to this side. God, that's annoying. A smarter man might have left one of these open for a jump like this. This is the same thing right here. So I got to go from here to here. That's actually good because we weren't able to find a length for that before. That's way too long. Let's see if we're able to find a length now. I've altered the length to my advantage. It needs to be slightly longer than orange, which I think is red. Orang. I was watching a 9-hour Fallout franchise review that I'm still getting through, and this reviewer did a really good job on most of the stuff. He didn't have as many bits as I would like to continue to pay attention. Like, I like it when the review gets a little silly in between a lot of the stuff, and that way it keeps you engaged for long-form content like that. But one of the things that kind of bugged me is that when he got to Fallout 4, he really had a chip on his shoulder. They were not kind to Fallout 4. And I understand a lot of the criticisms, but I think people have panned it needlessly. He really didn't seem to understand, like, his whole story-driven stuff. Like, Fallout 4 is a game that exists within the Fallout universe. It's not really so much of a Fallout game as it is a building game that happens to have a flimsy plot in it. Aquaponics process of filtering the fresh water through soil or grow media to grow surface plants like peppers. You didn't have to specifically say peppers on that, but I appreciate it. Yeah, it's neat. But yeah, I think, pretty bad rap on Fallout 4. There was definitely some, like, vengeance behind what they were saying. Like, they were not happy with that game. And I guess they just expected a different game out of it. We've gotten almost everything down. I think we might have made this circuit. That might be it, folks. That may have been the last connection. Not the most organized thing that I've ever built, but it is all down. Is anything, do we have any hanging chads or any little floaty bits? Everything's connected. We made a couple little cursed jumps. What about the base of the transistor on the right? That goes to a 0.2. That goes to the potentiometer. Wait a minute. That may be wrong. Shows more in Starfield how Bethesda's just tapping the same well over and over again without doing anything new. You know, I feel like they've drawn out Fallout plots and tried to make them do less because they want it to be a little bit, well, I don't know. I don't necessarily think that's a bad thing, but narratively having everything be every faction is about to explode at the end of the game, I don't know. It's hard to make a game like that over and over again. Like, what's the next Fallout after that going to do? Are these factions just going to endlessly have world-changing events at the end of every single plot? Or do you want to tell a story that's a little bit more contained within the plot? I mean, New Vegas was a bunch of factions. So, I don't know. Bethesda wanted to move in a direction of, like, building mechanics, and so rebuilding after, you know, the big one was, I guess, the focus. But I don't know if that means that it's, well, I don't really know. I'd have to really collect my thoughts on all this a little bit more to come down hard on one or the other side of it, whichever Fallout fan faction I would be joining. Okay, checking over the circuit. Ground, all the way here, all the way over here. Ground goes to 2 pins of the potentiometer. Yes, boop, boop. Pin 3 of the potentiometer goes to 2.2 UF capacitors. Now mine are ceramic. There's no plus sign on these, so you might assume that maybe they just didn't draw the right signal there. The symbol. Blah, blah, blah. They didn't put the right rune in there. It's possible. A ceramic capacitor has 2 flat leads because it can be connected in either direction. Fallout 76 is just as a fancy skin for a microtransaction machine. Yeah, and you know, maybe they learned that from Fallout Shelter. How much people are willing to pay for random stuff. Okay, so off of one of the 0.2s, we have our 1 oof. Off of one of the 0.2s, we have our 1 oof. And so that's this junction here. This is a little bit out of focus. That's this junction here, 0.1, and then it goes into the collector for one of the transistors. The collector for this transistor also goes to a 15 kilo ohm resistor to positive. 15 kilo ohm resistor to positive. That's that right there. Okay. We then have, what do we have? The other 0.2, which is coming off this way. Other 0.2 going to 1 oof. Sorry, 0.1 oof. 0.005. Okay, so we have 33K going to power. All right, hold on. I got to gather myself here because this is where things might get wrong. So we have the base of this transistor right here going to a 0.005. That should also go to the other potentiometer, which it does not. So here's our first issue. So the base to 0.05 and to 33K and to the 10K. That junction is here, all the way, so here, move over like this, over here. And it's not this, because this is the 0.2 here. That goes to the non-potentiometer side, the non-base side. Oh, which it does. So then this here has to go all the way out to here. So we need to jump that. Todd is a billionaire now. Is he actually? I don't think he is. I think we've quite gotten to that reality. Okay, it does not need to be that long. Okay, so much shorter than this. what do I have in my grab bag of wires here? Not really much in that size, huh? Maybe this one will do. So we go from the double junction of the pot. Actually, no, that one only goes to the 0.1. We go from here all the way over to here. Wait, that's really clunky. I can move this down. Wait, that one goes to the base, which is this side of it. So even shorter lead. Jeez. Move that down one, then I can see a little bit better. And then if I do maybe a red lead. Red lead here. Ah, red is way too short. This is what I'm talking about. I've got sort of this gap in capability where I can't go from end to end on this. So I'm either going to have to jump to another location. You know, never follow an electrical engineer to a second location. And then I need to come all the way out of this, maybe down here from the base. Oh God, this is terrible. I don't like this one bit. Just crossing over a resistor like that. It's not that you can't do it. It's just that it's like a faux pas. This is where we do cursed things now. Ooh, that was very clunky. So yeah, came from over here to there, up and over. Net worth is 10 million. Didn't he sell Bethesda to Microsoft? It's like a Notch sold Minecraft and became a billionaire. It's possible, I guess. It's weird that Minecraft or that Notch is a billionaire. I guess Microsoft has the funds to swing that kind of funk around. But that's crazy that like one game you become a billionaire. But Todd Howard's worth 10 million. And Bethesda's been making bangers for a while. Not even bangers. They sometimes they don't even work. But everyone still plays them though. You've all been played a fool. These games don't even work. Okay, so we have that junction has now been made. So the singular output of the second potentiometer up here goes to 33K to positive. That's the one that comes down and under. And then it comes clunkily up and over to get to the base of the transistor. And then we've got the 0.05 coming off of that, and that goes over here to the 0.2 right there. There's a 0.1 also, which I ain't seeing. Oh, that's this, 0.1. So 0.2, the other 0.2, which is this over to here, to the speaker lead, and then it jumps backwards to the 0.1, which goes over to the single output with a 33K. Whoops-a-daisy. I'm on the wrong pin, so this needs to go the other direction. Can I do that any other way? 33K, base, Lapida base, 0.05. No, it goes to the other side of it. It goes to the double side of the 10K. Sorry. So yeah, 0.1, double side. That goes to speaker. 0.1, this lead, also to speaker, also to 0.2. Yeah, I'm looking at this junction right here. It's just confusing. I think we're all set. I think I'm set to give this a test. That section there that you just saw is one of the most important parts about breadboarding a circuit, is you make all your connections and you kind of make them, I don't know, I usually sort of ADHD jump around and make certain connections, you know, make your ground connections, make your power connections, rearrange something, put something here, maybe this needs a larger lead, blah, 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 blah. Eventually you tick off all the boxes and all of your components are down on the board. Once that has happened, you then need to check over section by section. And you can actually take a highlighter, if you put this book into a photocopier When was the last time anybody did that? What do you mean, print a PDF? What's a photocopier? Put the book into a photocopier and make a copy of this page. And then what you do is you go through with a highlighter and you highlight the sections, because these junctions are not necessarily exactly what's on the board. These junctions, all they boil down to is this is connected to this, is connected to this, is connected to this, right? So you take those as a list of connections that need to be made. And so you double back on your circuit and you look, is this connected to this and this and this in some way, shape, or form? Yes or no. If it's not, correct it. And so you go over this with a highlighter and you highlight all of the in-between spaces between all of your components, and that'll check over all of your work. So now that we've done all of that, we know that all of these connections are confidently made, save for a couple that I didn't check, so there's obviously going to be errors in those. We will now power up the circuit and see if something explodes. I skip the last step on that, the whole check every single one, because if stuff explodes, that's good for me. That's content. That's entertainment. But I don't think this thing will explode. But we're going to give it 3 volts. Let me solder the speaker on. I need to solder the wires to the pin headers that we put on the board. And then we'll power it up and we'll see what happens. We'll see if we make the fish noise. The fish noise. Oh man, I should have gotten a bunch of monks chanting. You know, like, oh, so I could turn that audio bit on every time I say the fish noise. Ooh, the fish noise. This wire is not soldering. I'm trying to tin it because I'm just going to solder it directly to that pin header. There we go. Now, putting 3 volts through the speaker is going to be kind of rough. It might be a little loud. Might harm the speaker, actually. In which case, I'll have to purchase another skull speaker. I'll have to try that one again. My first stream on YouTube was the skull speaker project, and it failed. I was like, hey, welcome to my channel, YouTube. I do all kinds of fun project stuff here. And then I failed. So the positive lead of the speaker is going to be the one that goes directly to plus. This is going to be down here. Oh, picked up all the little scraps. Which one of y'all? This one's plus. Okay, so it goes there. That's funny. He uses the same color wire to get to the positive. All right, so it's barely attached, but that should be all right. And then I need leads, so I gotta move some stuff to get to my leads. I move a couple things to get to my leads. This is what happens when you got a good day of projecting going on. Everything is strewn all about. We can get rid of the microscope now. Let me put it back into its original configuration, which is looking straight down instead of across my whole shop. Oh yeah, it's not even inverted in this view. The microscope view is inverted because the webcam's upside down. There we go. We can get rid of that too. That wasn't the right one. Where is it? No, that's my blood glucose. Oh, it's doing all right. It's 183. Let's see. Which one is the scope? Scope is... where is that on this list? It's a huge list. No, that's a corgi. No, that's my skeleton. What the fuck is that? Get off of my... Get out of here! This would be... Oh, that one. There we go. Okay, cool. No more microscope. We will look on the thermal camera because it's good to see heat. In electronics, failure is heat. When things start to fail, they heat up. Thermal imaging, you can see heat. It is like a superpower. All right, so leads for the power supply. I've got these set up for doing other projects. What did we grab last time for this? These are already hooked up. Maybe we can just grab these. They're like under everything though. I think I need to find new leads. Let me just find a pair of clip leads over here. Those are not clips. Ah, the old easy hooks. These will do all right, though. So, banana plugs. Yeah, that was from when I was telling Chad about how I fell down the stairs here. One foot in front of the other is very easy unless your other foot gets in the way, in which case you tumble. And if you do that at the top of a flight of stairs, you have a lot of potential energy to then resolve with the rest of the staircase, which I did to the detriment of my bones. Man, if I didn't have that LAN party tomorrow, I probably could have smoked something. It's not legal in Pennsylvania. I mean, like, smoke like barbecue. Let's see. Leads, test leads, test leads. Where did I had them out. They were around. This book is too big. I need one of those old bureaus that you put a book on. You guys ever see those things? It's like the book stand. Exactly. Step 1, step 2, step 3, step 10, floor. I don't envy you, chat. You guys have this weird streamer, and your comment either elicits a chuckle or a barrage of abuse. I'm not blind to how I am. I know what it's like. The littlest things could set me off. It's like I'll read a comment with like the wrong intention, and I'll assume that they're being antagonistic. I've done it before, I'll do it again. And you know what? I'm sorry. I know I'm like this, and I'm not trying to change. Okay, positive and negative. I'm just using a vaguely, dark and light kind of thing. You can't necessarily match up the color of all the wires, so we bully you. It's only fair you bully us in return. Every time I try to say something, I get some kind of a goalpost moving squad comment to follow it up. I'm like, what do you mean? That's not the way that... And then they're like, oh, but I meant this instead. And it's like, okay, well, if you meant that, fine. It's always that little walk back. I hear the neighbor's dog barking outside, but Willow isn't here. She's just not here. I'm a mess without my dog. Okay, so let's go to 3 volts on this thing and see if anybody heats up. Power on. Okay. No heat. We're also not drawing any current. So one thing, if you're powering up a circuit for the first time, don't do what I do. Oh yeah, I did reverse those. I probably shouldn't. Oh yeah, we're putting reverse current into it. Look, I give stuff full voltage right away. And also, don't help me. Don't help me. You guys want chaos. Come on. Don't power it up initially. If you have a power supply that's worth anything, you should be able to tell the power supply to limit the amount of current out of it. So if you start off with your circuit and you're just getting ready to troubleshoot it, you limit that current to well below what it should be. Then you take a multimeter and you test how many ohms there are between positive and negative on your power supply. If there's an extremely low number of ohms, you got problems. If there's a growing number of ohms, it means you're charging a capacitor and things are probably okay. If you got something like 4 kilo ohms and up, things should be totally fine. If you've got no continuity between power and ground, maybe things are fine, maybe you don't have something hooked up. Either way, check the ohms of the power, positive to negative, and then limit the amount of current to a couple milliamps to start off. Plug it in, see if anything happens, see if anything rapidly heats up. Then you can bump it up in current until you get to your current requirements. I don't do that because I want chaos. I want stuff to pop. And I don't like to fake the popping. So here's negative. Here's positive. We should get fish noise. But we're not drawing any current. So, is anybody exploding? Nobody's exploding. I shall turn the knob. I am turning the fish knob. I am not getting a result. Wiggle our components a little bit here. Turn the other fish knob. Nothing. A whole lot of nothing. Wait, I heard something. Time to find out what noise a fish makes. It says, arrest everybody. Get him. I heard a little thud on the speaker. Just a little thud. Remember, all of our stuff is like slightly off. We should be getting like loud audio. I know it's not a 75 ohm. Well, there's a 57 in the part number. It's close enough. I don't know what the difference between this is, like what a 75 ohm speaker would do. So we can check on the O-scope and see if anything's happening here. Turns out the fish noise is a hoax. This is where we have to actually start measuring stuff. So if I turn on the O-scope, the O-scope is all caught up in doing module stuff right now. Hold on, let me power this up. It takes a full minute to power up. The only problem with these Android-based systems. We wait. Yeah, I don't know. I don't think I messed up building the circuit anywhere. Checked over my work. The polar capacitors shouldn't really matter. Maybe there's a connection I didn't make, but everything looks pretty good. I heard a little thud noise from the speaker. Obviously, if you run into troubles with something like this and you're in a rut and nothing's really working, you've already gathered all your parts together. So it's not that big of a deal to start over and just build it again. Just you know, swallow your pride, start over, build it again, rearrange things a little bit. Sometimes you can really have a revelation doing stuff like that. Yeah, this ain't doing nothing. So let's put no scope on the output because our speaker doesn't necessarily represent the appropriate device to translate. But I heard this thing go at one point. I need a lead. Hold on, let's put the scope up on the screen. You guys didn't even see me poking. I'm like pointing to stuff that you guys don't see. And this is something that I had to do with both friends and lab mates in college constantly, was to take their circuits, break it down to their bones, to my friends' bones. I killed a lot of people. Break it down to the bones and then rebuild it from nothing. Because sometimes the test setup gets old. You know, you keep adding stuff to the lab and you keep having to test different things. And so you keep having to add things and subtract things from your final setup. And it just gets it balloons out of control. And so you take a break and you clean the surface of the desk and you rebuild it sometimes. I'm going to try to avoid that because that'll take way too much time today. If we fail to make the fish noise, we will have failed everyone. And the solar flare will surely kill us all. I need to work on that VCO. I need to get my LED blinking engine up and running in that, because I'm going to need that for the cord VCO, which is going to be another software rewrite. All right, we have to make the fish noise. It's the noise we have to make. Why do you keep asking? What is this? What's going on here? Everything sucks. Hold on, let's get these cords out of the way. Jeez. This isn't solely a digital signal oscilloscope. It just has a lot of logic stuff because we do a lot of digital stuff here. We're making a foray into analog though, so because Julian has been after me for 30 years to make him a synthesizer. The final form of the lab bench is only reached upon death. They added morphing mechanics to my lab bench. All right, we've got these, which are convenient to probe in on a signal with. You know, this thing is a fully fledged probe. It's actually kind of nice. What you can do is plug in a different channel of the scope and hook that up to ground, and then you just have this probe to probe around with. And we may use that a little later on, but for now, the hook hat is the best thing ever. The hook hat on your scope, if you ever have the pleasure of buying a scope, make sure to keep this thing separate. It used to be back in the day you couldn't just hop on Amazon and buy a bunch of generic scope hats. These little clip hats were like just unobtainable, right? And you could probably get them from the company for like $1 billion. Probably do that on a government budget, but these things will walk. They'll go away. People will put them down on the desk, and then they just leave. They jump away. You keep these, and you keep these very sacred and in a special place. You make sure that these are always nearby. I'm very careful about that. But yeah, so scoping in on that, now I can just have a little jumper here that I can look around with. Now we'll take this on DC because this is a 3-volt circuit and it's not doing anything right now. So we'll take a look at this via DC. My ground lead is of course left because it's an easy hook, and these little hooks get damaged over time, and the little hooks on the end of the easy hooks can be very, very annoying to deal with. If you're buying stuff for making like a custom power supply of your own, check out Easy Hook. They're an American company and they make very, very nice products. These are easy hooks, but I'm also complaining about them. All right, so this right here, hooking it up to power. We've got nothing going on. I keep all my probes separately in their original bags. Always a pain in the ass to get them out. They stay around. Yeah, I keep a drawer for all of that stuff, and these are still in their bags. They'll eventually migrate out of it, but this is all my weird stuff, and I keep a specific drawer for the extra leads, extra hats, etc. You can buy extra hats now, and I've got a couple sitting in here from other oscilloscopes that were not taken care of. Not by me, other people. This is one of the weirder things that I have. It's a little leaning stand for your probe. So this is just a little weighted plastic stand, and you can hook it up with your probe, and it'll hold it against stuff. Weird. When you need it, it's extremely useful. 98% of the time you won't. These have a nice click to them. They have a different style of click than the normal probe click ends. I guess they must have done something. There must be a little split ring in there. Okay, so ground is to ground. Let's check to see that we've got power. There's 3 volts. We're on this trace, so let's get rid of the other traces that we don't need. We're doing basic probing today. Much like the aliens, we're doing basic probing. So we definitely have 3 volts on this line. 3 volts connects to the speaker directly here. Speaker directly, we have 3 volts there. It connects to 3.3K over here. That's correct. And then it connects to 15K over here. That is also correct. So on this side, it would be 15. Let's see what's actually going to our speaker. Our transistors aren't flipping, it seems. Because this should be fluttering to ground. Change some of these. It's just noise. That almost did something, but not quite. Okay, so BC 548 might not be an equivalent. The transistor originally called for is a 2N 2N3565. 2N3565. Let's look for a better antique electronics supply. Oh, jeez. Mauser. Oh, God. That is old. New old stock. 2N3565. 3565, yeah. All my probes tied in a giant spaghetti knot in a box with about 400 easy hook jumper wires and BNC adapters. That sounds not fun. You should get those cable organizers that you can screw into the wall, and it's just like a fork, and you just put all the cables on the fork. I don't know how many 222s I have. I've got a couple little like adapter things with 2 2s in them. Yeah. 2N3565 is primarily intended for general purpose and low-level applications. This was for use in the original harmonic percolator, Fox tone machine, and the Sam Ash fuzz box. Neat. Problem is, this calls up a bunch of transistor equivalent websites, and I find these to be kind of confusing. Oh, well, there's forums posts. That might be okay. Hello, I was planning to build a 2-piece pepper spray, and I messed with my stock of transistors. And now I only have one, 2N3565, and I can't order overseas just one transistor. So is there a good way and easy to find equivalent for this? Is there a good and easy to find equivalent for this transistor? Or am I doomed? However, 5088-3904. That's what I was doing. I was doing the 3904. Produce a slight octave effect has only been observed in older and lower gain pieces. I wouldn't worry about it. Just use any transistor with HFE 200 to 300. So let's see. Noise. HFE, I don't know what rating that is. HFE. High frequency envelope? I'm just putting words in there. Oh yeah, so it might be a situation where it's like any DC current gain. Oh, okay. The transfer function stuff. It was there. You were on it. And 2 to 3, 1 to 8. By all means, it should be working. The fish noise is a hoax. You may have thought that there was a fish noise, but you were wrong. There is no fish noise, and I've proven it here. That's what I've done this. I've done it. I've completed it. That's right. There is no fish noise. Everybody's out there talking about fish. They go, what is the fish noise? What is it? Well, it turns out it's nothing. You can't take that away from me. Fish don't even talk. When was the last time you read something written by a fish? Huh? It looks like this. It's nothing. This is fish. It's just a drawing. It's a sectional drawing of the ocean. There's nothing here. And that's sand. There's a little sun in the corner, and it's got a face on it. We're not drawing any current. We're not really triggering the transistors at all. Dolphins aren't fish. Well, this should be high Z, so why did that do it? Whales aren't fish. It's another, you're just naming mammals. Sir. A saltwater tank in one of the fish tanks used to squeak from time to time with the actual flux situation. When I saw the fish move, I heard the noise. Yeah, some make little noises. Mr. Limpet. I don't know what that is. Let's check the base of this one. We've got a slight voltage on the base. So whatever's supposed to be happening here ain't happening. Whatever little triggering is supposed to be occurring, there's supposed to be a back and forth between these transistors. That's not happening. Could it be a bad connection? Yeah, absolutely. It could be a bad connection. It could be all kinds of stuff, actually. I mean, that kind of looks like something intentional is happening there on that lead of the pot. It actually kind of looks like something that's eventually supposed to be making noises. I need a big sip of water. Nice, tasty upstairs water. It's actually filtered. It's not sink water. Well, I think I was just shorting that out. So this would be the other lead. That's coming up, going down from ground. That should be where we're seeing like a signal output. Feels like these are doing nothing. And nobody is using current. Ugh, analog troubleshooting is always a nightmare. Always a nightmare. Sometimes you put this stuff together and it works the first time, and that's always a nice place to be. But with analog circuits, it seems like it's always torture no matter what. Maybe it's the speaker here that's cursed. It's cursed beyond reasonable doubt. It's always going to be a problem for me. It'll be in my family for generations. It's there. These two branch out. One of the leads goes there. This one goes to the point one. The point one goes over to... Yeah, that pin's in the right spot. Of course, these seem like barely connected. Where's my fish noise? Huh? I was told that there would be fish noise. I'm going to move the speaker connection down. It's right here. I was told there would be fish noise. On the collector, yeah, that's right. The collector, and then from the collector, we go to that junction of the 0.1 off. So collector, hold on a minute. No, that is all connected. Yeah, 0.1 off is here. And then this one goes to the 0.2. It goes down from that to the 0.2. 0.2 goes to this junction here, which is also on the potentiometer, down to ground. That's sort of a bias thing there. The only thing I could think that would be happening, well, no. No chance. What's going on here, buddy? Where's my fish noise? Well, whatever's happening there, that's kind of funky. That's usually when a probe lead slips. Oh, yeah, the power lead slipped off. Reconnect ground. Boop. Nice and stable. Which is not what it's supposed to be. I found a video on YouTube of fish noise. I don't need to listen to that. Dalinel cerebellum? Cerebrum. Danionella cerebrum. I don't need to read that. What's up, Camara? How you doing? We're supposed to be making the fish noise, and by all means, you can clearly see that we've built a fish noise circuit. I mean, everybody knows what a fish noise circuit looks like. We're not hearing a fish noise. And in fact, nothing is wibbling around on our levels here. Take it easy, Timbo. Let's see here. So yeah, the effect of the potentiometers is not readily evident. The transistors don't really have much to go on here. I mean, that should be slightly triggering the NPN if we're at just like a sub-volt. So what do heck? You know, we've got verified 3 volts, verified ground, collector, not really doing anything. Give it more juice. I mean, I might, just because I don't care if this blows up or not. Like every time I jump in on this base, it seems to be discharging. It comes over here and it connects to the 0.2 and the 0.1. Yeah, that's this and this. That's right here. And I need to hit it with a fish. Push the fish button. My own little whopper button. Like I see some stuff going on up here. Some little jumps that are being made. And it might just be the inconsistency of my board affecting it. But it seems like maybe that's something that... No, not really. No, not really. Oop. Slips completely out. Let's see. Everything I know with circuits is telling me that stuff should be happening here. By all means. There's probably a way that I could arrange this circuit so that it's a little easier to understand. But fundamentally, I'm not really sure what the hell is supposed to be going on in this thing. Here's the circuit. For all of you playing at home. The fish caller. Based on a hopeful theory, the fish will be attracted by strange underwater noises. Consists of two transistor tone generator, two transistor tone generator, and a small speaker mounted in a waterproof case for lowering into water. Changing the settings of pots gives a variety of tones. I'd really be interested in listening to these variety of tones, but none of this stuff seems to come to fruition whenever I try it out. Seems like if I split out the circuit into... One transistor is pulling down positive. The other one is pulling through the speaker. And then one part of it goes through there, the other part of it... We've got everything that's on there. All right, that's enough all caps for you. You're done with all caps. The 2.2 off. No, there's no 2.2. It's 0.022. So we have like 220 picofarad extra. Oh boy. You can increase the size of the... Whatever. You got to go into your own accessibility settings, man. Disco house days. I think I've been there before. Why don't you work, circuit? Oh, there was something weird. What was that all about? That might have been my leads slipping. Might have been my leads slipping up a little bit. Just make sure our leads are good. I mean, there's always a chance that all of this behavior is being caused by a slightly bad connection on something. I thought I heard the speaker squelch just a little bit at one point, but we're not really getting any performance out of this, and this should be creating two tones. We're hitting the fish threshold. Everybody, everything's fish right now. Where's my fish noise? Why are you not noising like fish? All right, since we're too dumb, take a look at transistor frequency generator. Was it transistor noise or transistor frequency? 2 transistor tone generator. And it's not generators. 4 transistor function, frequency generator, 3 steps. Let's do 2 transistor tone generator to shed some light on how these things should work. Why? Why is there so much electronics? What is that? Google Images. Google Images is a little bit crap, but it's a little less crap. Multi-tone generator circuit. Okay, this will tell us how different things affect the transistor. So we've got power connected to 9 to 12 volts connected to positive here. So upping the voltage might be something that we do. We have a 100K potentiometer here that's going to the base of a 2N646. It's pulling it down, and actually, well, this is activating the base of a 2N3904. I've got a 100 nanofarad capacitor with 100K. So it discharges. Where does it discharge to? Because this, I guess it discharges through the transistor, and then the 100K builds it back up when you press the switch. And then somehow fish love you or something, and women fear you. I think that's what goes on. I'm going to up the voltage. So I'm going to take the power here, and I'm going to go to 3 volts. So I'm going to go to 4 volts. 3.98 volts. So there goes the O-scope picture. Let's make that a little larger. A little bit more verticality. Still nothing. What's happening on the base of one of our transistors? We still have a sub-volt voltage. Yeah. Whoa, 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 whoa. What was that? Was that the fish noise? If it makes like a sonar ping. Oh man, you could imagine getting in trouble with the military because you made a fish noise maker. That's 6 volts. I don't know if I should go any higher than 6 volts. Nothing's heating up, but you know, no fish noise is being produced. Make the fish noise. Push the whopper button. Make the fish noise. Come on. I mean, I guess it would be down to the transistor, but these are generic BC 548s. BC 548s. We've got 6 volts going to this thing. I doubt going up to 9 is really going to do much, but you guys, I know you're excited about this project, even though we're doing the dumbest circuit in the entire book. You don't have to look it up if you don't want. Popular Electronics, March 1971. So there's the article. The link is in the chat. Oh, bother. More like, pff. Huh? All right. I don't know if I want to actually open that up to see what the article contains. I think what I need to do is get a different transistor. I think I need to find a different transistor. There's no reason why these shouldn't work. We're going up to 9 volts. 6, 7, 8, 9 volts. I don't think it's a voltage thing. I don't think it's a voltage thing. There's a little bit of movement right about. None of these components are particularly affected by the voltage except for maybe the transistors, but the transistors aren't doing anything. So hold on a minute. If I got the pinout for the transistor wrong, it's possible. It's possible. Let's see. Where are my transistors? So these were BC 548s. I think my trouble with all of these analog circuits has been the transistors. I've had a lot of trouble getting these circuits, the purely analog tone creating and frequency generating ones. I've had a lot of trouble with. I think it might be down to like transistors and pinouts for me. Like BC 548, silicon NPN. They should have a common pinout though. It should be collector base emitter. And that's the way we have it hooked up. How much current? Oh, it's been flatlining on current. There's been nothing happening with current. No current has been running through it because the transistors aren't switching. So if the transistors aren't switching, this whole circuit just sits here static. Hold on, let me pull up that article. Nobody from YouTube has said anything. I'm gonna out my name. Just don't pay attention to it. Yeah, it's all connected. All right. Nobody's been watching me on YouTube because I didn't stream for a little while because I forgot to hit start. Okay, so let's take a look at that link. It'd be nice if they had, was it page 70 something? 70 pages of this crap. Can you imagine getting this in the mail? And this is your only, dear God, man. This is your only source of electronics information. I wonder what, you could actually reconstruct that check from this picture. We could get a little AI on this. That check is as good as mine. You get your information from stuff like this. There's so little to do in the 70s that you have to resort to reading about stuff like this. Page is like 70 something. We're on 60. You get these in Popular Mechanics. I know I skew older. I skew older for my crowd. That's why the 1974 circuit book is so popular. We're back in the day. Too many people in my crowd have used these before in an actual logical manner. Let's see here. Not as like something to glue to something else, or a save icon in real life. 78 or something. It was page 76. I ain't seen no schematic here. Ooh, Heathkits. Remember Heathkits? Dolbyization. Potential fly in the Dolby ointment. No, we're not. That's not the right one. Video scene. Was it, am I missing a digit? The article begins on page 76. Oh, I might not have linked to the right one. Where's my fish circuit? Hold on, this should tell me. March 1971, page 84 to 85. So there's a typo. 84 to 85. Oop. Gyration, anyone? Don't mind if I do. Dubbed a gyrator because its electrical action is analogous to that of a mechanical gyroscope. Woo! Sign me up for that gyrator. I'm having more fun finding it. Don't tell me where to go. We found the gyrator. We've never seen the gyrator. If you told me exactly what page I was supposed to go to. Now I feel like I'm doing it because you told me. I'm doing it just because I want to, okay? Oh, there it is. There we are. Pisces 1. What a pretentious name. Squelch circuit will be used in the PLSC adapter, so that's a different thing. Reader's circuit submitted by Vincent X. That's a flashing circuit. That's figure 2, so we're up a little bit on this thing. A fishy project. Oh, the author just got tickled pink saying that. They were like, ooh, this is the best of my career. I used the ones that was 8-inch wide and big silver discs. The really old school ones are the ones that have a big locking platter, and so you've got a loose disc in a sleeve, and you very carefully take it out of the sleeve and you put it into something that looks like a cake press or some kind of like an industrial thing. And it's got a huge lever that you lock it down with. Those are amazing. I had a chance to grab one from a lab that I was cleaning out, and I should have saved it. I should have had it sitting on the shelf behind me. Many fishermen feel that blah 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 blah. Anyway, if you want to try it this spring, Techniques Incorporated, blah blah blah, New Jersey, is making available for their Pisces 1 a 2-transistor tone generator whose schematic is shown in figure 2. I have a feeling some stuff was left out. This is figure 1, by the way. That's just a squelch circuit. Varying the 2 potentiometers produces a wide variety of sounds, hopefully, and probably not, including one that will attract the fish you're after. Pisces 1 is available at $10 in kit form. Oh, so it's a kit. Comes with a pair of waterproof plastic bags. I'm glad. I'm glad the bags are waterproof. I'm just glad they're waterproof. I'm just glad. 2 transistors for $10. Well, this is 1972 or whatever. So all the information that we had before is here still. It's just not behaving the way that we want it to. And it could be down to what I built. could easily be down to what I built. I could have just built a dud here. And so taking it apart and building it again is something that could be prudent. The more I up the voltage, the more this is prone to popping. It could also be that my transistors have a different pinout, although everything that I've looked up has said that that is the pinout of the transistors. So my capacitors are pretty accurately valued. They're only slightly off. We should be just getting slightly different tones out of this thing. Or it could be some kind of a connection issue. That's why I continually kind of press down and wiggle some of these components to see if they'll do anything. The only problem is my 60 hertz AC coupling can come through in the circuit as weird stuff sometimes. What we should be seeing is tones. We should be seeing waves on this line, and we're just not seeing it. This is why I like op amps a little better, because they function a little bit more consistently. Oh man, we failed the fish circuit. I was hoping the fish circuit would actually do stuff though, you know? But anyway, I guess we all go shuffle off and die in the giant electromagnetic storm that is heading towards the northeast. And if North America dies, the world is coming with us. So have fun in the Stone Age, everybody. Maybe the fish could help me with this, yes. What the hell's going on? Okay, so we probe around the circuit and we're seeing, I mean, this is like advocating for spreading out and actually making the circuit much larger than this so that I would be able to probe in and see what stuff is happening when. I'm turning the voltage back down to 3. 2.99. There's still no current going through this though. No, Nibiru's not going to get us. It's the electromagnetic storm. Like a lightning storm in space. Like a balloon and something bad happens. What if we reference on positive voltage? No, that's not going to do it. I was thinking, what if we reference from positive voltage and we look at the other side of the transistor? But I don't think that's really that's not going to really be revealing. Oh, that one jumping into the negative like that is a little strange. Where's that coming from? Why are you not triggered? Why are you not producing 2 tones? I have a feeling this is just like 2 tones that are on top of each other, and so it's going to make like a woo 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 kind of noise. That's what I thought that other circuit was, and then we looked at the circuit, and it was one piece of a very large circuit. It's possible that they wouldn't have left stuff out. I don't think they would have left stuff out on the circuit. We do have an alternative fish caller that makes a clicking sound. But I don't have a transformer. What is that all about? It uses a crystal earphone too. That's not a part that we have outside of 1970s and 80s electronics kits. I remember the crystal earphone. I used to have one. It was a little in-ear thing. It was just a piezo element. Living up to your name, I guess. Once all the technology's gone, low tech is going to take over the world. Why? Why don't you work? Let's find a different transistor. Let's see if it's down to the transistors. So we're looking for a 2N3565 equivalent. They said the 2N3904 is an equivalent. I don't have any. I don't know what happened. I thought I had a bunch of those. I've got 2N3904s in surface mount form, which maybe we can dig up. Well, the surface mount transistors aren't going to allow me to spread the leads out and get them to go where I want them to. If I did all the leads in a row, I probably could get some of the transistor things that I built recently. But I mean, let's just throw stuff at the wall, I guess. BC549, what is that? We can just see if we can find a transistor that just will happen to work. 549. Yeah, okay. Same thing as kind of the same thing that we're using, slightly different. 80 volts collector base. Which one is this, NPN or PNP? And where's my pinout? This is one of those. They keep it all the way down here, huh? Pins 1, 2, and 3. Okay. Yes. Leg end. Huh? on 9294. This is 49. Okay, so we're not that one. Why do they make this so difficult? BC549 datasheet. Go down here to this one. Epitapaxable. BC549. Collector, base, emitter. CBE. Okay. Let me turn off power to our fish noise generator. I'll bring you guys back over here with this. Pluck. Pluck. The BC549. These are much higher voltage though, so I don't know if this will exactly do what we want it to. So collector here, base here, and the emitter goes to ground. So the collector, let's see, base goes here, or sorry, collector here, emitter here, base here. Okay, next one. Start these a little bit so that they're easier to work with. So this one goes here, where its collector hits the speaker. Base goes to, well, that would just short it out. Wait a minute. Oh yeah, it goes to this line all the way out here. So this all the way out here, and then the emitter. Damn it. I caught on the seam and bent it the wrong direction. There we go. Collector, base, emitter. Just like that. Okay. Different transistor. Let's go. Let's try it out. Let's put the lead on the speaker wire there. And let's give it 3 volts. Nothing. Great. A bunch of piss. Yeah, okay, so I don't know what the deal is. I mean, there's no reason why this should be not working. And I'm pretty sure that the circuit itself works. Did a light just go out behind me? What happened there? Oh, it's getting dark out. Let's see. Yeah, this is another 110 to 800, where they said 100 to 200. So I mean, yeah, a little bit, focus in a little bit more on that DC current gain. But other than that, I mean, it should still be doing something. We should probably be in the saturation region, not the saturation, but the region of voltages where the transistor wants to do stuff. So possibly another part of our circuit is bad. I wouldn't know what though. 12 volts, 3, 4, 5, 6, 7, 8, 9, 9 volts, 10, 11, 12, 12 volts. Nothing. I'm pretty sure the transistors work. It's just they're not, something's not getting through. Maybe it's down to the capacitors that I'm using. Maybe they're not working. This thing isn't working at 12 volts though. Let's go back down to 3 before something pops. Later down the line. Like, not immediately. Something wouldn't pop immediately. It's down the line. I'd do something and then it'll short something out and the tool would heat up. Now we know power is getting all the way down to this thing because if I plug into the power right there, we can see that's 3 volts. So 3 volts is there. At the base, we probably should be seeing something that resembles a wave, but it seems like we get this weird discharge from it. It's like a dog whistle, only fish can hear it. Well, but then the oscilloscope would be able to hear it, and the oscilloscope hears nothing. Oh, that's the wrong one. This one. No, wait. Yeah, it's just through a coil. This should be jumping down to ground. The transistors should be triggering and pulling this down. We know that 5 volts is getting to our 15K, and the 0.1 off we know is getting to the right location. Then it would go through another 0.02, which are these 0.022s. Pull components and see if something happens. Short components and see if something happens. Eh. Is it too strong of a pull-up? Yeah, I know. It should be a waveform. It should be two waveforms. Or is it just one? I forget. The two transistors are making the waveform, right? I think so. One of them should be pulling on a voltage input, and the other one should be, well, it's pulling that triggering input down. The other one pulls the other trigger input down. So they should be working in tandem with one another. Try another location. It could be the board. I don't want to move everybody at once. That'd be very annoying. So we've gone through a couple hours building this thing, and I don't know. Maybe I could rearrange things on the board a little bit better, so that there's actually a response. Whoa, whoa! Oh, that's just the lead going through my body. This is the 60 hertz noise. Yeah, we're all doomed. We're pretty much we failed at the 11th hour. Everything has gone wrong. Why wouldn't this work? I'm starting to think that like it is down to the transistors, because like we built the I mean, I could check this over again and we could take a look, but it's hard for me to pull the circuit up at the same time on the screen. Let me do this. So it's not very pretty, but it should represent all of the appropriate parts of the circuit. The speaker, positive voltage coming in, 3 volts. That's here. Positive voltage goes to the speaker. It's this right here. So that goes to the positive lead of the speaker. Then it goes through a big stinky resistor right there. So that's this one over here. And that's 15 kilo ohms. And it goes to the collector of the transistor. Wait a minute, I might have already found the issue. Okay, so that one needs to go to this pin over here. I missed this one. That goes like that. So do we get fish noise? No, power's still on and nothing's happening. Yeah, okay. Oh, here, I'll put this on the speaker lead, I guess. And then let me turn the scope on the screen here, just in case we happen to be futzing around with it and something accidentally starts working. So this here is the pull down all the way on the left to the collector of the left side transistor. The base of the left side transistor, the emitter, by the way, goes to ground. It's power and ground. That's all correct. So that's this portion of the circuit right here. All correct. Now we move on to the next portion of the circuit. So we come out of the base here, and we have 3 things connected. One of them is a 33K to positive. So we follow this lead. Up and around, and then here's the 33K to ground. Oh no, never mind, power. Darn. That would have been a really good smoking gun if that was actually what was wrong here. But this is indeed going to power. So we check power here. Why did this stop? Hold on. Oh, power's off. We'll turn power off for this so you guys can see what I'm probing. Power's on. We're at 3 volts. Why I not get 3 volts here? Hold on a minute. Oh, the lead slipped. I see. There you go. So yeah, 3 volts right there. So 3 volts, 33K. Here, shares of the base. Also goes, and again, we're right here. We're right here. The 33K has a 0.1 off coming off in this direction, because this is the, no, wait a minute, that's the wrong place. 103J goes to the other collector. Hold on a minute. That goes down there, and it goes to the collector, whereas we have this one coming down, and it's going directly. Okay, here's the first mistake. So the collector's here. Collector goes to the base. Oh, that's wrong too. Wait a minute. Oh, there's all kinds of stuff. All right, hold on a second. All right, let me turn power off because this is a... Yeah, let me to figure out my circuits on my own. I'll figure it out. Don't worry. Collector to this one was which value? Oh, wait a minute. Which one is which? One's one off. Yeah, this is the one off right here. So that one is this that goes over and down, and that goes to the other base. Okay, so that is correct. That goes to the other base, and then that goes to the 0.2 on this side. So 0.2, one off. So that would be this, and this is the one off collector, and then it goes through the point. Hold on. You go back down there. Go back. There we go. It could be the speaker's impedance might be an issue. I don't know if it would be the issue. I should at least see something going on here. But let's see. So from there, where are we? We've gone over here and down. The base of this right side, or the base of the left side transistor goes to the white wire, and it goes all the way over here, and it goes up and around. The base here, all the way up and around, and then there's the 33K, which is this one here, going to power, and then it goes to the singular lead of the potentiometer. The double lead of the potentiometer goes through a 0.1 UF, which is 103J, down to 0.1. There's a lot of stuff on the side. So 0.1 goes several places, one of which is the speaker. That's the black wire going down. The collector is right underneath that. So then jump over to 0.1, and then the speaker also jumps all the way over to the 0.2, which is down here. That's what those two are meeting up at. And then 0.01 is, no, wait a minute, that's wrong. 0.005. 0.05 is all the way out here. So it actually goes, oh God, this junction is all over the place. So and then back over to here, and then over to here. And this is the 0.005 going to the base here. Let me interrupt you during your explanation. 63 months. Thank you so much, PyroEsp. I'm not really doing an explanation. I'm just reviewing where everything's going. This went together very hastily, so things are all over the place. But as such, I don't really see any errors in anything that I've done. The base of this one goes over to... Well, that might be an error. No, that's correct. 1 ... And then this one goes over to... This is the point... Sorry, the one UF. It's the surface mount part that we got. That goes over to the collector, which is connected to the other stuff. This is exactly correct. Everything I have in here is exactly correct. The other side of the 0.2s, which are branching out in either direction, goes here, which goes to the singular lead of the cock castle. No, to the potentiometer. And then the other two leads of the potentiometer go to ground, which goes through this, which goes down to ground. Everything is correct. Where's my fish noise? I was told that there would be fish noise if I created this circuit. Do you think maybe they left something out of the circuit in order to screw up people so that their product would be something people would buy? They tried to keep it secret. 2 days off of work, hell yeah. Put power to it again. No fish noise. How do I increase the impedance of the speaker? Whoa, wait a minute. Hold on. Oh, wait, no, that's just noise. That's just regular old noise. That looks a little bit more like something, but I think that might just be ground noise. Oh yeah, because my lead slipped. Damn it! It's always these leads slipping. Oh good, now there's did nothing. We failed at producing the fish noise, chat. It's okay to be embarrassed. What if I put a 75 ohm resistor on this thing and we just observe it in the O-scope? Let's see what I got. It does not go, as you can see. There's a 75K. Oh wait, 75 ohm. Hold on a second. 75 ohm. We got an 8 ohm. 470, 75R. Here we go. I'm going to simulate a coil, I guess. We're safe from the fish. Well, we're not safe from the solar flare. We're all going to get solar flared. There's nothing left for us, chat. Chat, is this Skibbity? Says a middle-aged man in his basement alone on a Friday to nobody, to the furniture. All right, unplug the speaker. Put 75 in here. At least something is happening. There's a little bit of heat. There's still no current being drawn by this thing, too. Yeah, it just doesn't do. I don't understand it. This happens to all of my crap. The flar. You forgot the E. Omae wa shinderu. Okay, so this isn't happening. I don't know what the hell happened with this circuit. Analog stuff is extremely frustrating. I don't you know, there's a lot of stuff that goes wrong with this thing. And maybe the sooner I can actually master an analog transistor oscillator, the sooner I can actually like put something like this together and have it work, because I know what parts to sub in. I think that's where I've gone wrong, is that I just don't know what the sub parts are supposed to be. If I used polar capacitors, I don't think anything different would happen. So I'm very frustrated because I've got two modules of this synthesizer that are not functioning properly because of these same kind of issues, where I just don't know how to troubleshoot analog electronics properly. And it frustrates me to no end. I mean, I'm pretty good at stuff, and I'm good at troubleshooting like projects, but when it comes down to actually troubleshooting like something that I've built like this, where I've made some circuit substitutes, but not like a lot of fundamental things. A lot of the stuff in this is the correct stuff. So what the hell happened? Do I need a matched pair of transistors is the other question. Do I need an actual matched pair in order to get this thing to work properly? In which case, I don't know if I have any left. I might have one or two parts that are a matched pair of transistors. So, with that being said, I think I'm out of content. Well, it's about stopping time anyway. I'm like 10, 15 minutes from when I should probably get going. 4 hours and 30 minutes is not an amazing amount of time for stream, but I like to kind of reset our palette on Friday. And again, if there's no content, I'm not going to keep going. Can we try the 2N2222s? I don't have any that are ready to be breadboarded. I might have some that I put into like little surface mount carrying things, but I'm not going to try to dig those up right now. The fish noise didn't happen. I think maybe what we need to do with the big book next time is I need to find a transistor oscillator in it. Just something simple. Transistor oscillators, like put this together and it'll make a woobly wave on the screen, right? That's what I thought we were doing the time we did this before last, which was 3 weeks ago. We tried this. I opened the book up. I said, let's make the ear woobler noise. And it was supposed to make this woobly wave, but there were these external connections. And so we dug into it a little bit, and it turns out that the pleasing noise generator wasn't just this cute little circuit that you could put into a book of circuits. It was added on to a much larger oscillation like engine. Nice try with the fish noise. Thank you for the $1.77. I really appreciate that. Maybe chicken would have been easier. Well, what am I doing about dinner? I'll figure it out. I gotta go figure out dinner. I have enough stuff that I can smoke something, I think, on Sunday, but Saturday I'm busy all day. So pretty much it's just, I'm gonna gear up and get ready for that. And then, oh, I have shopping to do. I gotta go do shopping. So I'm gonna go out into the world and maybe I'll die on the street. But just make sure, remember, before the solar flare, you guys need to pose yourselves in some kind of an environmental storytelling position. So like, you know, jump off the toilet and wherever you land, point towards your weapons cache so that your skeletons are posed properly, okay? That's my PSA for the day. Yeah, enjoy the end of all electronics tonight. I don't know when this is supposed to happen, to be honest. I don't even know if I'm going to be able to see anything because it's so cloudy here, but we're apparently going to have a big solar flarington. So the big book will come out next Friday. Tuesday, I don't know what we'll do. Wednesday or Thursday, I don't know what we'll do, but we'll probably be working on a lot of Burn the Subs because there's a lot of stuff still left to do. Until then, take care, have fun, solar flare. Oh, you wait until now to leave a YouTube comment? Damn it! I forgot the end card. Here's the end card. Here's social media and stuff if you guys feel like following it. This does not go on to the YouTube thing, so you'll probably have to like write it down in a notebook and then type it into your computer, or you could just join us at Twitch. Yeah, okay. See you guys on Tuesday. Bye. Where's my... There it is.